Google Data Analytics Professional Certificate, Full Bootcamp 2026. Genre, Computers and Technology. Target audience, career switchers, aspiring data analysts, certification candidates. Style, instructional, visual heavy. Structure model, Gemini 3 Pro Preview. Content model, Gemini 3 Pro Preview. The data mindset. Launching your analytics journey. Narrated version. 0 hours, 0 minutes, and 0 seconds. Chapter 2. The Art of Inquiry. Defining problems and objectives. 12 minutes and 26 seconds. Chapter 3. Data ecosystems. Sourcing, ethics, and integrity. 24 minutes and 34 seconds. Chapter 4. Spreadsheet mastery. Cleaning and organizing your data. 37 minutes and 18 seconds. Chapter 5. Speaking the language of databases. Introduction to SQL. 50 minutes and 10 seconds. Chapter 6. Data transformation. Advanced SQL for analysis. 1 hour, 1 minute, and 22 seconds. Chapter 7. Uncovering insights. Statistical thinking and analysis. 1 hour, 13 minutes, and 10 seconds. Chapter 8. Visual storytelling. Principles of effective design. 1 hour, 25 minutes. Chapter 9. Dashboard dynamics. Getting started with Tableau. 1 hour, 35 minutes, and 24 seconds. Chapter 10. The share phase. Crafting compelling dashboards. 1 hour, 48 minutes, and 27 seconds. Chapter 11. Programming power. Fundamentals of for analytics. 2 hours, 1 minute, and 58 seconds. Chapter 12. Scripting success. Data wrangling and visualization in R. 2 hours, 14 minutes, and 47 seconds. Chapter 13. The capstone strategy. Building a portfolio-ready case study. 2 hours, 27 minutes, and 14 seconds. Chapter 14. Navigating the job market. Branding and interviews. 2 hours, 38 minutes, and 52 seconds. Chapter 15. Beyond the certificate. AI, machine learning, and life analysis. 2 hours, 52 minutes, and 13 seconds. Chapter 1. The data mindset, launching your analytics journey. Sections 1.1. Demystifying the role of a modern data analyst. 1.2. The life cycle of data. Ask, prepare, process, analyze, share, act. 1.3. Thinking like a detective, curiosity and context in analysis. 1.4. Overcoming imposter syndrome and building technical confidence. 1.5. Setting up your toolbox, an overview of the 2026 tech stack. Welcome to the starting line. If you are reading this, you have likely decided to pivot your career, upgrade your skills, or simply satisfy a burning curiosity about how the world works. You are standing at the threshold of a profession that is part science, part art, and entirely essential to the modern economy. In 2026, data is no longer just a byproduct of business, it is the engine. But data without interpretation is just noise. It is static, overwhelming, and often misleading. That is where you come in. As a data analyst, you are not just a number cruncher. You are a storyteller, a detective, and a strategist rolled into one. This chapter isn't about writing code or memorizing formulas, we will get to that later. This chapter is about calibrating your brain to see the world through the lens of data. Let's build your foundation. 1.1 Demystifying the role of a modern data analyst. There is a common misconception that data analysis is solitary work performed in dark rooms by people who love math more than humans. Nothing could be further from the truth. The modern data analyst is a bridge builder. You stand between the raw, messy reality of information and the decision-makers who need clarity. Your primary job is to turn "I think" into "I know." When a marketing director asks, "Why are sales down?" they don't want a spreadsheet with 1 million rows. They want an answer. They want to know if it was the pricing, the season, or a competitor's new ad campaign. Figure, a split-screen illustration-style diagram. On the left side, depict a chaotic cloud of binary code, scattered icons of documents, and messy jagged lines labeled raw data. On the right side, show a clean, illuminated light bulb and a clear path forward labeled actionable insight. In the middle, place a silhouette of a professional connecting the two sides with a bridge structure labeled the analyst. Use a clean, flat vector style with a blue and gold color palette. In the landscape of 2026, the tools have evolved, but the core mission remains unchanged. We use AI assistants to write boilerplate code and automated pipelines to clean data, but the logic is human. You provide the context that machines cannot replicate. Think of yourself as a translator. The database speaks in SQL, the stakeholder speaks in business goals. You must be fluent in both. If you can explain a complex trend to a non-technical manager in under 2 minutes, you will be indispensable. 1.2 The life cycle of data: ask, prepare, process, analyze, share, act. To navigate the ocean of information, Google established a framework that has become the gold standard for junior analysts. It provides structure to the chaos. We call it the data life cycle. Whenever you feel lost in a project, return to these 6 steps. Step 1. Ask. Before you touch a single key, you must understand the problem. This is the diagnostic phase. If a doctor operates without asking where it hurts, they are dangerous. Similarly, an analyst who dives into data without a clear question is wasting time. We define the problem and identify the stakeholders' needs here. Step 2. Prepare. This is where we gather our raw materials. Where does the data live? Is it in a database, a spreadsheet, or a third-party API? You need to assess the credibility and integrity of your sources. In 2026, we also must strictly evaluate data privacy and ethical sourcing, ensuring we aren't using biased or prohibited data. Step 3. Process. Real-world data is messy. It has typos, missing values, and duplicates. Processing, often called cleaning, is the act of scrubbing the data so it is ready for analysis. It is often the most time-consuming step, but it is non-negotiable. Bad data in means bad insights out. Figure, a circular process flow diagram showing the 6 steps: ask, prepare, process, analyze, share, act. Each step should have a distinct icon. Ask, ? Prepare, folder, process, wrench gear, analyze, magnifying glass, share, graph, chart, act, checkmark. The flow should be clockwise with arrows connecting them, indicating an iterative loop rather than a straight line. Professional corporate color scheme. Step 4. Analyze. Now, the detective work begins. You sort, filter, and aggregate the clean data to find patterns. Is there a correlation between temperature and ice cream sales? Did the website crash when traffic spiked? Here, we use logic and tools to let the data tell its story. Step 5. Share. Analysis is useless if it stays on your laptop. You must visualize your findings. This involves creating charts, dashboards, and presentations. The goal is accessibility. Your visualization should be intuitive enough that someone can understand the trend within 5 seconds of looking at it. Step 6. Act. Finally, we apply the insights. The stakeholders take your recommendations and make business decisions. While you might not make the final call, your analysis empowers the decision. When the business changes strategy based on your chart, the cycle is complete. 1.3 Thinking like a detective: curiosity and context in analysis. Technical skills are the how, but curiosity is the why. To succeed in this field, you must cultivate a relentless sense of wonder. When you see a number that looks wrong, do you delete it, or do you investigate it? A data mindset requires you to constantly ask, does this make sense? If your analysis shows that a retail store sold 0 units in December, a computer accepts that as 0. A detective asks, was the store closed for renovations? Was there a supply chain failure? This brings us to context. Context is the background information that gives data meaning. Without context, data is dangerous. Data point interpretation without context, interpretation with context. Figure, a conceptual illustration comparing data vs. context. On the left, show a puzzle piece isolated on a white background. On the right, show that same puzzle piece fitting perfectly into a larger, beautiful landscape picture, revealing its true purpose. Label the left data point and the right contextual insight. Use warm lighting to highlight the completed puzzle. Never accept a dataset at face value. Always research the surrounding circumstances. Who collected this data? When? Why? By adding context, you transform from a calculator into a consultant. 1 point for overcoming imposter syndrome and building technical confidence. Let's have a real conversation. You are likely looking at the road ahead: SQL, Python, R, Tableau, generative AI prompting, and feeling a knot in your stomach. You might think, I'm not techy enough for this, or everyone else already knows this stuff. That feeling is imposter syndrome, and I want you to know that senior data scientists at Google feel it too. The field of data moves so fast that everyone is constantly learning. The goal is not to memorize every function in Excel, the goal is to know how to find the answer. In 2026, the most valuable skill is not encyclopedic knowledge, it is adaptability. If you encounter an error message, you don't need to know the fix instantly. You need the grit to troubleshoot it. Actionable advice for confidence, * embrace that search, professional developers search for answers constantly. It is not cheating, it is research. * focus on concepts, syntax, the code itself, changes. Logic, how to solve the problem, lasts forever. * celebrate small wins, did you write a formula that worked? Did you clean a messy spreadsheet? That is a victory. You belong here. Your unique background, whether in retail, nursing, teaching, or sales, gives you domain knowledge that a pure computer scientist lacks. You bring a human perspective to the data. Lean into that. 1.5 Setting up your toolbox, an overview of the 2026 tech stack. As we move through this bootcamp, we will equip you with a specific set of tools. We call this the tech stack. While new apps appear daily, the foundational 4 pillars of data analytics remain steady. 1. Spreadsheets, Excel. The Google Sheets. Do not underestimate the spreadsheet. It is the workhorse of the business world. For quick calculations, small datasets, and initial data viewing, nothing beats the grid. We will master pivot tables and advanced functions that make you look like a wizard. 2. Query languages, SQL. Databases are where big data lives. SQL, structured query language, is how we talk to those databases. It is the most requested skill in job descriptions. We will learn to extract exactly what we need from millions of rows of data with just a few lines of text. 3. Visualization tools, Tableau, Looker. These tools turn your numbers into art. They allow you to build interactive dashboards where stakeholders can filter and drill down into the data themselves. This is where your work becomes visible to the executive team. 4. Programming and AI, Art Python copilots. For complex statistical analysis and automation, we use programming languages. In this bootcamp, we will focus heavily on R, as per the Google certificate path, but we will also touch on how 2026 AI copilots can help you write and debug this code faster than ever before. Figure, an isometric illustration of a digital toolbox. The toolbox is open, revealing 4 distinct compartments. Compartment 1 contains a green grid icon, spreadsheets. Compartment 2 contains a database cylinder icon with a magnifying glass, SQL. Compartment 3 contains a colorful bar chart icon visualization. Compartment 4 contains a stylized snake and letter art icon interwoven with a futuristic microchip node, programming and AI. The style should be modern, clean, and high-tech. You do not need to install everything today. We will introduce each tool exactly when you need it. For now, just understand that these tools are your superpowers. They extend your ability to think, process, and persuade. Get ready. The world is full of questions, and you are about to learn how to find the answers. Chapter 2: The Art of Inquiry, Defining Problems and Objectives. Sections: Section 2.1, Mastering the Ask phase, Turning Business Pain Points into Questions. Section 2.2, Structured Thinking and the Scope Methodology. Section 2.3, Communicating with Stakeholders to Manage Expectations. Section 2.4, Crafting Smart Goals to Guide Your Analysis. Section 2.5, Real-World Scenarios, Distinguishing Root Causes from Symptoms. In Chapter 1, we established that a data mindset is your compass. Now, we must learn to read the map. The most dangerous person in a data department isn't the one who doesn't know how to code, it is the one who answers the wrong question perfectly. You can build the most sophisticated machine learning model in 2026, utilizing the latest cloud infrastructure, but if it solves a problem that nobody cares about, it is wasted effort. This phase of the data analysis lifecycle is known as the ask phase. It is often the most neglected step because it feels slow. When you get a dataset, the urge to immediately dive into SQL or Python is overwhelming. You want to see the rows, count the values, and make charts. Resist that urge. Before you touch a single data point, you must act as a detective. You need to understand the crime scene before you start dusting for fingerprints. This chapter is about the art of inquiry, learning how to turn vague business frustrations into precise, solvable data problems. 2.1 Mastering the Ask phase, Turning Business Pain Points into Questions. In the professional world, stakeholders rarely hand you a clearly defined math problem. They hand you feelings, symptoms, and complaints. A VP of marketing won't say, "Please calculate the correlation between our email open rates and churn probability." They will storm into a meeting and say, "Why are we losing so many customers this quarter?" Your job is to translate that pain into a project. This requires a shift from passive listening to active interrogation. We call this translation. Figure: detailed infographic illustration showing a translation funnel. At the top, a wide funnel intake labeled business noise catches chaotic speech bubbles with text like "sales are down, customers are angry, and it feels slow." These pass through a filter layer labeled the analyst's lens. Emerging from the bottom is a neat, organized stream of rectangular cards labeled specific hypotheses, key performance indicators, and data requirements. The style should be modern, isometric, clean vector art with a blue and gold color palette. The translation process. Identify the pain, listen for emotional keywords: frustrated, worried, crashing, lagging. Identify the subject: who or what is being affected. New users? The mobile app? The queue for budget? Identify the metric: if this problem were solved, what number would change? If a stakeholder says, "Our new product launch was a disaster," you must drill down. A disaster could mean low sales, high returns, or bad reviews. Those are three completely different data investigations. By asking, "How do we define disaster in this context?" you might discover they actually mean we had high traffic but low conversions. Suddenly, you aren't analyzing the product, you are analyzing the checkout process. You have just saved yourself weeks of work. 2.2 Structured Thinking and the Scope Methodology. Structured thinking is the safety net that prevents you from getting lost in the weeds. When facing a complex problem, experienced analysts use frameworks to organize their thoughts. One of the most effective frameworks for the ask phase is the scope methodology. It ensures you and your stakeholders agree on the boundaries of the project before you begin. Situation: what is the current context? Is the company expanding? Shrinking? Launching a new feature? Context dictates how you interpret data. A 5% drop in sales is bad in a boom year, but a miracle in a recession. C. Complication: what has changed or gone wrong? This is the specific trigger for the analysis. Example: competitor X lowered their prices, and our daily active users dropped. O. Objective: what is the desired outcome? Do not just list, create a dashboard. The objective should be a business decision. Determine if we should match the competitor's price or improve our feature set. P. People: who is this for? A technical CTO wants raw numbers and error logs. A marketing director wants trends and demographics. Tailor your output to the audience defined here. E. Execution and exclusions: what will you deliver, and equally important, what will you not do? Defining exclusions prevents scope creep, the slow expansion of a project until it becomes unmanageable. Using scope protects your time. When a stakeholder asks for just one more thing later, you can refer back to the scope document you both agreed on. Figure: a clean, corporate-style checklist graphic titled the scope card. The graphic resembles a physical clipboard. Next to each letter, S, C, O, P, E, there is a blank line filled in with handwritten style text. Example text: S, Q3 launch, C, user drop-off at payment, O, increase conversion by 2%, P, product team, E, Tableau dashboard, no predictive modeling. The lighting should be soft, focused on the clipboard. 2.3 Communicating with stakeholders to manage expectations. Data analysis is a customer service role. Your customers are the internal teams who need your insights. The hardest part of this relationship is managing expectations. Stakeholders often think data is magic, that you can press a button and the computer will tell them the future. You must gently anchor them in reality without killing their enthusiasm. The yes and technique. When a stakeholder asks for something impossible, like "can you tell me exactly why every single customer left?" avoid saying no, that shuts down collaboration. Instead, try, "I can't track the thoughts of every user, but I can group them by behavior patterns to show you the top 3 reasons for leaving." Would that help? Handling ambiguity. Ambiguity is the enemy of analysis. If a manager says, "I want to see data on user engagement," you need to freeze the conversation. Engagement is a buzzword, not a metric. Use a clarifying table to force specificity. Vague request analysts clarifying question specific metric. Notice how the clarifying question guides the stakeholder toward a specific number. This allows you to measure success later. If you don't define success now, you can't prove you achieved it later. 2 Point for crafting smart goals to guide your analysis. Once you understand the problem and the stakeholders, you need a mission statement. We use SMART goals. You may have seen this acronym in general management, but in data analytics, it has a specific flavor. Specific: the goal must target a specific area for improvement. Measurable: you must be able to quantify or at least suggest an indicator of progress. Actionable: the goal must lead to a decision or action, not just a knowledge. Relevant: it must matter to the business bottom line. Time-bound: the analysis needs a deadline. The evolution of a goal. Let's look at how a goal matures from a rough idea to a smart analytical objective. Draft 1, too vague: find out why shipping is slow. Draft 2, better analyze shipping times to see where delays happen. Draft 3, smart: identify the top 2 distribution centers causing delays of greater than 48 hours in the Northeast region using Q3 logistics data to be presented by next Friday. In Draft 3, we know exactly what data to pull: Q3 logistics, Northeast region, what criteria to filter for, greater than 48 hours, and when it is due. There is no room for confusion. 2.5 Real-world scenarios, distinguishing root causes from symptoms. This is the final and most critical distinction in the ask phase. You must distinguish between the symptom, what hurts, and the root cause, the disease. If you treat the symptom, the problem comes back. If you find the root cause, you solve it forever. The 5 Whys technique. Sakichi Toyoda, the founder of Toyota, developed a technique called the 5 Whys. It is remarkably simple. When you see a problem, ask why 5 times. Let's apply this to a data scenario. Problem: revenue is down 10%. Symptom: why? Because fewer people are buying subscriptions. Why? Because traffic to the sign-up page has dropped. Why? Because our primary Facebook ad campaign stopped performing. Why? Because the creative assets, images, are 6 months old and users have ad fatigue. Why? Because the design team wasn't assigned to refresh them. Root cause. If you had stopped at the first why, you might have lowered the price of the subscription to attract buyers. That would have been a disaster because price wasn't the issue, marketing freshness was. Scenario: the broken website. Imagine you work for an e-commerce retailer. The customer support lead tells you the website is broken. Customers are complaining they can't pay. The symptom: high cart abandonment rate. The knee-jerk reaction: the server is down. Panic. The analyst's inquiry: you look at the data. The server uptime is 100%. You segment the data by device. Desktop users are fine. iOS users are fine. Android users. 90% failure rate. The root cause: a recent update to the Android app broke the To Submit button layout on small screens. By digging past the symptom, website broken, to the root cause, Android CSS error, you save the engineering team from checking the servers and direct them specifically to the mobile front-end team. That is the power of the ask. Summary. The mask phase is about setting the trajectory of your project. If you are off by 1 degree at the launch, you will miss the moon by 1,000 miles. By using structured thinking, scope, communicating clearly with stakeholders, setting smart goals, and drilling down to root causes, you ensure that your eventual analysis will be relevant, actionable, and impactful. Now that we have defined our problem and our objective, we need the raw materials to solve it. In the next chapter, we will discuss where data lives, how it is generated, and how to get your hands on it.
Chapter 3: Data Ecosystems, Sourcing, Ethics, and Integrity. Sections: Section 3.1, Navigating the Prepare Phase, Where Data Lives and How to Get It. Section 3.2, Structured versus Unstructured Data, Knowing the Difference. Section 3.3, The Ethics of Analytics, Privacy, Consent, and GDPR Compliance. Section 3.4, Identifying and Mitigating Bias in Data Collection. Section 3.5, Metadata and Governance, Ensuring your foundation is solid. In Chapter 2, we learned that asking the right question is the compass for your journey. Now, we have to look at the terrain. You have defined your problem and identified your stakeholders, but you cannot solve a puzzle without the pieces. This brings us to the prepare phase of the data analysis lifecycle. This is the stage where strategy meets reality. It is where you determine what data you need, where to find it, and most importantly, whether you can trust it. Think of yourself as a chef. Chapter 2 was about designing the menu. Chapter 3 is about sourcing the ingredients. You wouldn't cook a Michelin star meal with wilted vegetables or expired meat. Similarly, you cannot build a robust analysis on a foundation of flawed, biased, or unethical data. In this chapter, we will explore the complex ecosystem where data lives. We will learn to distinguish between high-quality resources and noise, and we will have the hard but necessary conversations about ethics and privacy. 3.1 Navigating the Prepare Phase, Where Data Lives and How to Get It. Data is rarely sitting in a neat little package waiting for you to open it. In the real world, data is messy, dispersed, and often owned by different entities. Your first job is to understand the origin story of your information. Data sources generally fall into 3 categories: first party, second party, and third party. Understanding the distinction is vital for assessing reliability. First-party data is data collected by your own organization. It is the gold standard. You know exactly how it was gathered, why it was collected, and how current it is. For example, if you work for an e-commerce company, your own sales records are first-party data. Second-party data is essentially someone else's first-party data. This happens when an organization shares their data directly with you. Imagine a partner company sharing their customer satisfaction surveys so you can cross-reference them with your sales. It is reliable, but you have slightly less control over the collection definitions. Third-party data is aggregated from outside sources. This often comes from data brokers or public repositories like government census data. While useful for broader context, it carries the highest risk. You are removed from the original source, meaning you can't easily verify how the data was cleaned or filtered before it reached you. When sourcing data, always prioritize originality. The further you get from the source, the more likely it is that errors have crept in. We often use the acronym ROCCC to evaluate data quality. Figure: photorealistic diagram of 3 concentric circles on a sleek glass surface, illuminated by soft blue and white LED lighting. The center circle is labeled first party, internal, and glows brightest. The middle ring is second party, shared, with connecting distinct lines. The outer ring is third party, aggregated, showing a diffuse, cloud-like network of connections. High-tech, clean aesthetic. Reliable: is the data accurate and consistent? Original: can you locate the primary source? Comprehensive: does it contain all necessary critical information? Current: is the data relevant to the timeframe you are analyzing? Cited: has the data been vetted or credible? If your data fails the ROCCC test, no amount of advanced coding in Python or R will save your analysis. 3.2 Structured versus unstructured data: knowing the difference. Once you have located your data, you need to understand its shape. In 2026, data doesn't just look like rows and columns in a spreadsheet. It comes in waves of audio, streams of video, and mountains of text. We categorize this into 2 main buckets: structured and unstructured data. Structured data is highly organized. It fits neatly into the rows and columns of relational databases and spreadsheets. Think of customer IDs, transaction dates, stock prices, and zip codes. It is easy for computers to search and easy for humans to query using SQL, structured query language. Unstructured data lacks a predefined data model. This includes emails, social media posts, photos, satellite imagery, and audio recordings. This data is heavy, messy, and rich with context. Here is a quick breakdown of how they differ. Figure: a split-screen 3D illustration. On the left, a clean, organized architectural wireframe library with identical labeled boxes, representing structured data. On the right, a vibrant, chaotic artist studio filled with loose photos, audio waveforms floating in air, and scattered handwritten notes, representing unstructured data. Cinematic lighting, 8K resolution. Feature: structured data, unstructured data. As an analyst, you will likely start your career working primarily with structured data. However, the industry is shifting. The ability to extract insights from unstructured data, like analyzing customer sentiment from thousands of product reviews, is becoming a superpower in the job market. Do not be intimidated by unstructured data. Just recognize that it requires a different set of tools and a bit more patience to prepare. 3.3 The ethics of analytics: privacy, consent, and GDPR compliance. We must pause here for the most critical topic in this book. Just because you can access data does not mean you should use it. In the digital age, every click, swipe, and step creates a data point. Behind every one of those points is a human being. As data analysts, we are the stewards of that information. We have a moral and legal obligation to protect the people represented in our datasets. Data ethics encompasses the privacy, transparency, and accountability of data usage. It is not just about following the law, it is about doing what is right. Personally identifiable information, PII, is any data that can identify a specific individual. This includes names, addresses, social security numbers, and even IP addresses. Before you ever begin analysis, PII must be anonymized or removed unless absolutely necessary and authorized. You must also be familiar with regulations like GDPR, General Data Protection Regulation, in Europe and various state-level privacy laws in the US. These laws grant individuals the right to be forgotten and require explicit consent for data collection. Figure: a close-up, macro photography style shot of a digital lock icon made of glowing fiber optic cables, resting on a circuit board. The lock is green, signifying security. Surrounding the lock are faint, blurred binary codes representing data streams. The focus is sharp on the lock, symbolizing the priority of privacy. If you are working with a dataset, ask these questions. 1. Did the people in this dataset consent to be here? 2. Is the data being used for the purpose they agreed to? 3. Could this analysis harm or disadvantage the individuals involved? If the answer to the last question is yes, or the first two are no, you must stop. Bring your concerns to your stakeholders. Integrity is the most valuable currency you possess as a professional. 3.4 Identifying and mitigating bias in data collection. Data is often viewed as objective truth, but it is collected by humans, and humans are inherently biased. If your input data is biased, your output analysis will be biased. This is the concept of garbage in, garbage out. Bias often creeps in during the collection phase, long before you open a spreadsheet. Sampling bias occurs when your data doesn't represent the population you are studying. For example, if you survey customer satisfaction only by emailing people who bought a product in the last week, you are ignoring everyone who stopped buying from you a month ago. You are hearing only the happy voices. Observer bias happens when people behave differently because they know they are being observed. This is common in workplace productivity studies. The data you collect might reflect best behavior rather than reality. Confirmation bias is a trap for the analyst specifically. This is the tendency to search for or interpret data in a way that confirms your pre-existing beliefs. If you believe a marketing campaign was a success, you might subconsciously filter out metrics that suggest otherwise. How do we fight this? First, acknowledge that bias exists. No dataset is perfect. Second, practice inclusivity in your data collection. Ensure your sample includes diverse demographics and viewpoints. When you present your findings, be transparent about the limitations of your data. It is better to say, "This data represents our active users," rather than claiming, "This represents everyone." Figure: a conceptual 3D vector art illustration showing a magnifying glass hovering over a scattered group of colorful dots. Most dots are blue, but the magnifying glass is specifically focusing on a small cluster of red dots, ignoring the rest. A warning icon floats nearby. Minimalist, clean corporate style. 3.5 Metadata and governance, ensuring your foundation is solid. Imagine walking into a massive library where all the books have been stripped of their covers, title pages, and ISBNs. You can open them and read the text, but you have no idea who wrote them, when they were published, or what genre they belong to. This is what data looks like without metadata. Metadata is data about data. It provides the context required to use the information effectively. It includes details like *source, who created this file? *date, when was it created or last updated? *size, how many records are included? *description, what do the column headers actually mean? Good metadata is a love letter to your future self. 6 months from now, when you reopen a project, you will not remember what the column labeled var_1 stands for. Metadata ensures you don't have to guess. This falls under the umbrella of data governance. Governance is the formal management of data assets within an organization. It defines who is responsible for data quality, who has access to what, and how security is maintained. As a junior analyst, you might not write the governance policies, but you must follow them. This means using standardized naming conventions, documenting your steps, and storing files in the correct secure locations. By respecting metadata and governance, you ensure that your work is reproducible. Science relies on reproducibility. If another analyst cannot take your data and your notes and get the same result, you haven't done analysis, you've done magic. And in business, we don't pay for magic, we pay for reliable insights. In the next chapter, we will roll up our sleeves. We have our question, and we have sourced our ingredients. Now, it is time to start cleaning and processing. Get ready to get your hands dirty.
Chapter 4, Spreadsheet Mastery, Cleaning and Organizing Your Data. Sections, Section 4.1, Moving Beyond Basic Entry, Efficient Navigation in Excel and Sheets, Section 4.2, The Process Phase, Techniques for Spotting and Fixing Dirty Data, Section 4.3, Essential Functions for Transformation, VLOOKUP, XLOOKUP, and IF Logic, Section 4.4, Pivot Tables Power Hour, Summarizing Massive Datasets, Section 4.5, Documentation Habits, Creating a Change Log for Reproducibility. We have arrived at the workshop. In Chapter 2, you learn to ask the right questions. In Chapter 3, you sourced your ingredients and checked them for quality. Now, we enter the process phase of the data analysis life cycle. This is where the rubber meets the road. It is widely estimated that data professionals spend 60% to 80% of their time cleaning and organizing data, leaving only a fraction for actual analysis. That statistic might sound discouraging, but I want you to reframe it. Cleaning data is not a chore, it is an investigation. It is where you get your hands dirty and truly understand the texture of your information. You cannot build a skyscraper on a swamp, and you cannot build a career-defining insight on messy data. In this chapter, we are going to treat spreadsheets, whether you use Microsoft Excel or Google Sheets, not just as calculators, but as powerful engines for transformation. We will turn the raw, chaotic data you collected in the previous chapter into a pristine dataset ready for analysis. Section 4.1, Moving Beyond Basic Entry, Efficient Navigation in Excel and Sheets. There is a distinct difference between someone who knows how to open a spreadsheet and a professional analyst. The difference is usually audible. A professional analyst uses the keyboard more than the mouse. When you are dealing with datasets containing 50,000 rows, scrolling with a mouse wheel is not just inefficient, it is a liability. You risk missing patterns or accidentally dragging cells where they don't belong. To master data, you must master the interface. Your goal is speed and precision. We need to build muscle memory that allows you to navigate massive datasets without thinking, freeing your brain to focus on the data itself. The control key is your anchor. The most critical shortcut in your arsenal is the control key, or CMD on Mac, combined with arrow keys. This combination allows you to jump to the edge of your data regions instantly. If you are at the top of a column with 10,000 entries and press Ctrl plus down arrow, you will teleport to the last non-empty cell. This is vital for quickly checking if your dataset has unexpected gaps or the null values halfway down the list. Selecting data with precision. Navigation is good, selection is better. By adding Shift to the mix, you highlight data as you move. Ctrl plus Shift plus down arrow selects everything from your active cell to the bottom of the dataset. This is how you apply formatting or formulas to an entire column in seconds, rather than dragging the fill handle for 5 minutes. Figure, a high-contrast, macro-style illustration of a mechanical keyboard focusing on the Ctrl, Shift, and arrow keys. The keys are glowing blue, indicating active use. Overlaying the keys is a holographic projection of a spreadsheet grid with a selection path highlighted in neon green, showing movement from cell A1 to A1000 instantly. The lighting is cinematic and tech-focused. Freezing panes for context. As you navigate deep into your data, you will lose sight of your headers. Analyzing row 5402 without knowing what the column headers are is a recipe for error. In both Excel and Sheets, freezing panes locks your top rows or left columns in place. Always freeze your header row immediately upon opening a raw dataset. It keeps your context anchored no matter how deep you dive. Section 4.2, The Process Phase, Techniques for Spotting and Fixing Dirty Data. Dirty data is the industry term for information that is incomplete, inconsistent, or formatted incorrectly. It is the grit in the gears. If you feed dirty data into a visualization tool or a machine learning model, you will get nonsense on the other side. The process phase is about sanitization. We are looking for common enemies, duplicates, extra spaces, inconsistent formatting, and outliers. The invisible enemy, trailing spaces. One of the most frustrating errors in data analytics occurs when apple that does not equal apple. To the human eye, they look identical. To a computer, the first one has a leading space, making it a completely different text string. This often happens during data entry or when importing from legacy systems. The trim function is your sanitizer. It removes all spaces from text except for single spaces between words. Equals trim A2. Run this on your text columns to strip away the invisible garbage that breaks your formulas. Uniformity with proper, upper, and lower. In 2026, data comes from everywhere: web forms, mobile apps, and handwritten scans. You will often see a name column that looks like this: John Doe, Jane Doe, and Bob Smith. Before you can group these by name, they must be uniform. Use casing functions to standardize your text. Equals upper, A2, converts to Jane Doe. Equals lower, A2, converts to Jane Doe. Equals proper, A2, converts to Jane Doe. Removing duplicates. Duplicate rows can artificially inflate your numbers. If a sales transaction is recorded twice, your revenue report is lying. Both Excel and Google Sheets offer a Remove Duplicates tool in the Data tab. However, use this with caution. Always ask yourself, is this actually a duplicate, or just two similar transactions? Always back up your raw data before using destructive cleaning tools. Figure, a split-screen comparison graphic. On the left, a dirty data spreadsheet shows chaotic entries, inconsistent capitalization, red error triangles, and noticeable whitespace gaps. On the right, a clean data spreadsheet shows the same data, but perfectly aligned, standardized in capitalization, and error-free. A glowing arrow points from left to right, labeled the process phase. Section 4.3, Essential Functions for Transformation, VLOOKUP, XLOOKUP, and IF Logic. Once your data is clean, you often need to reshape it. You might have sales data in one sheet and customer demographics in another. To analyze them together, you must join them. This is where lookup functions come into play. They are the digital equivalent of looking up a phone number in a directory. The evolution from VLOOKUP to XLOOKUP. For decades, VLOOKUP, vertical lookup, was the king of the analyst's toolkit. You will still see it in legacy files, so you must know it. It searches for a value in the first column of a range and returns a value in the same row from a specified column. However, VLOOKUP is fragile. If you insert a new column, it breaks. It creates a processing drag on large sheets. Enter XLOOKUP. This is the modern standard. It searches one array and returns a result from another. It defaults to an exact match, unlike VLOOKUP, handles errors gracefully, and can search in any direction. Equals XLOOKUP, lookup underscore value, lookup underscore array, return underscore array, if underscore not underscore found. Imagine you have a customer ID in cell A2, and you want their email address from a separate contacts sheet. Equals XLOOKUP, A2, contacts, 8A, contacts, B, not found. This formula says, look for the ID in A2 inside the contacts sheet column A. If you find it, give me the value from column B. If you don't find it, say a not found a dot. Logic gates, the IF function. Data analysis is often about categorization. If revenue is above $10,000, mark as high value. Otherwise, mark as standard. The IF function allows you to encode this logic directly into your grid. Equals IF, B2 greater than 10,000, high value, standard. You can nest these to create complex logic trees, essentially programming decision-making capabilities into your dataset. Section 4.4 The Pivot Tables Power Hour, summarizing massive datasets. If functions and cleaning are the preparation, pivot tables are the cooking. This is where you take 100,000 rows of transactional data and summarize it into a clear, concise table in 3 clicks. A pivot table does exactly what the name implies. It allows you to pivot or rotate your data to view it from different perspectives. You are trading granularity for summary. The anatomy of a pivot. When you create a pivot table, you are presented with 4 quadrants. Rows, what groups do you want to list down the side? E.g., product categories. Columns, what groups do you want across the top? E.g., months. Values, what math do you want to do? E.g., sum of revenue, count of orders. Filters, what do you want to hide? E.g., exclude 2024 data. Figure, a clean, isometric 3D diagram showing the pivot concept. A large, flat grid of raw data blocks is being funneled into a central mechanism that rotates and sorts them. Out the other side comes a neat, compact 2x2 summary cube. The 4 quadrants, rows, columns, values, filters are labeled on the mechanism with icons representing lists, headers, calculators, and a funnel. Analyzing patterns. Don't just drag and drop randomly. Ask a question first. I want to see total sales by region. Drag the region to rows. Drag sales to values. You immediately have your answer. Pivot tables are not just for reporting, they are an exploratory tool. They let you interview your data rapidly, testing hypotheses to see where the story lies. Section 4.5, Documentation Habits, Creating a Changelog for Reproducibility. We end this chapter with a topic that separates the amateurs from the pros, documentation. You might clean a dataset perfectly today. But in 6 months, when your manager asks, "How did you come up with these numbers?" will you remember that you filtered out test users and converted GBP to USD at a rate of 1.25? Likely not. And if you cannot reproduce your results, your analysis is worthless. The changelog. Every major project needs a changelog or a README tab in the spreadsheet. This is a simple text record of every transformation you apply to the raw data. Your changelog should look like this. Date, analyst, action taken, reason. This simple table protects your reputation. It shows integrity. It ensures that if you go on vacation, a colleague can pick up your work and understand exactly what happened to the data between the prepare phase and the analyze phase. You have now mastered the art of the cleanup. Your data is structured, standardized, and documented. The noise has been removed, and the signal is ready to be detected. In the next chapter, we will leave the spreadsheet grid behind and begin asking even tougher questions using the language of databases, SQL.
Chapter 5, Speaking the Language of Databases, Introduction to SQL. Sections, Section 5.1, Why Databases Beat Spreadsheets for Scaling Analysis, Section 5.2, Navigating the BigQuery Interface and Environment, Section 5.3, Syntax Essentials, Writing Your First Select, From, and Where Queries, Section 5.4, Filtering and Sorting, Extracting Precisely What You Need, Section 5.5, Common SQL Errors and How to Debug Them Efficiently. In Chapter 4, we rolled up our sleeves and got our hands dirty in spreadsheets. You learned the tactile satisfaction of cleaning data row by row, scrubbing away errors, and organizing information into a readable format. But as you advance in your analytics journey, you will inevitably hit a ceiling. Spreadsheets are incredible tools, but they have physical limits. When you are dealing with millions of rows of data, which is standard in 2026, clicking and dragging formulas simply isn't feasible. The application freezes, the file crashes, and your analysis grinds to a halt. Welcome to the world of SQL, Structured Query Language. If spreadsheets are the hand tools of data analysis, SQL is the heavy machinery. It is the industry standard for talking to databases, and it is the single most important technical skill you will acquire in this bootcamp. Do not let the word code intimidate you. SQL is not like building an app or writing complex algorithms. It is a language designed to be read and written very close to plain English. By the end of this chapter, you won't just be reading data, you will be commanding it. Section 5.1 Why databases beat spreadsheets for scaling analysis. Imagine a local library. A spreadsheet is like a single bookshelf. You can see every book, rearrange them by hand, and quickly find what you need. A database, however, is the entire New York Public Library system. You cannot physically walk through every aisle to find a specific book, it would take a lifetime. Instead, you use a catalog system to request exactly what you need. That request system is a database management system, and the language you use to make the request is SQL. Databases are superior to spreadsheets for three primary reasons: scale, integrity, and speed. While a spreadsheet might struggle with 1 million rows, a database like Google BigQuery can process billions of rows in seconds. This allows you to analyze historical trends over decades rather than just weeks. Furthermore, databases separate data storage from data analysis. In a spreadsheet, if you accidentally delete a cell, that data might be gone forever. In a database, you are merely viewing or requesting a copy of the data. You cannot accidentally break the raw data just by looking at it, which provides a massive safety net for beginners. Section 5.2 Navigating the BigQuery interface and environment. For this certification, we use Google BigQuery. It is a data warehouse that lives in the cloud, meaning you don't need to install heavy software on your computer. You simply log in via your browser, and you have the power of a supercomputer at your fingertips. When you first open BigQuery, the interface can look stark compared to the familiar grid of Excel or Sheets. The screen is generally divided into three main areas: the Explorer pane on the left, the editor window in the center, and the results grid at the bottom. The Explorer pane is your map. It lists your projects, datasets, and tables. Think of a project as a house, a dataset as a room in that house, and a table as a filing cabinet in that room. You must know the path to the filing cabinet before you can open it. Figure, a detailed, annotated screenshot diagram of the Google BigQuery interface, 2026 UI update. Callout boxes with drop shadows highlight three specific zones. 1. The left sidebar, Explorer, labeled the map, where data lives. 2. The top center, Query Editor, labeled the console, where you write code. 3. The bottom, Results, labeled the output, where data appears. The style should be instructional, clean lines, white background, emphasizing the layout logic. Before you write a single line of code, you should always click on a table name in the Explorer and view the Schema tab. The schema tells you the column names and the type of data, integer, string, date, inside them. Attempting to query a database without looking at the schema is like trying to drive to a new location without looking at the map. You might get there, but you will waste a lot of gas guessing the route. Section 5.3 Syntax Essentials. Writing your first select, from, and where queries. SQL syntax is built on a very logical sentence structure. It follows a grammar that is remarkably similar to how you would order food at a restaurant. If you were to order a pizza, you might say, "I want a pepperoni pizza from Domino's." In SQL, we don't say "I want," we say "select." We don't say "from the menu," we say "from." The basic structure of almost every query you will ever write starts with these two keywords. Here is the anatomy of a basic query. Select. Column_name. From. Dataset.table_name. Let's break this down. Select tells the database which columns you want to see. From tells the database where those columns live. If you wanted to see every single column in a table, you would use an asterisk symbol, which is often called a star or wildcard. Select. From. Customer_data.purchase_history. While select asterisk is great for a quick peek, professional analysts rarely use it for final reports because it pulls unnecessary data, which slows down processing. It is always better practice to be specific. Note that I capitalized the keywords select and from. SQL is technically not case-sensitive, it will run even if you write it in lowercase. However, writing keywords in caps is a universal convention. It makes your code readable, distinguishing the commands from the data itself. Section 5.4, Filtering and Sorting, extracting precisely what you need. Data analysis is rarely about looking at everything at once, it is about finding the signal in the noise. This is where the where clause comes in. It acts as a filter, removing rows that don't meet your specific criteria. Going back to our pizza analogy, I want a pizza, select, from Domino's, from, where the topping is pepperoni, where. Select. Customer underscore name. Purchase underscore amount. From. Customer underscore data dot purchase underscore history. Where. Purchase underscore amount greater than 50. In this query, the database ignores every transaction of $50 or less. It only returns the big spenders. You can also combine conditions using and or. If you want purchases that are over $50 and occurred in 2026, you simply chain the logic. Once you have filtered your data, you usually want to organize it. This is done with the order by clause. By default, SQL sorts in ascending order, AZ or 1 to 10. If you want to see the highest numbers first, you add desk, descending, at the end. Select. Customer underscore name. Purchase underscore amount. From. Customer underscore data dot purchase underscore history. Where. Purchase underscore amount greater than 50. Order by. Purchase underscore amount desk. Notice the order of the commands, select, from, where, order by. You cannot change this order. You cannot order data before you tell the database where it comes from. Memorize this hierarchy, it is the skeleton key to SQL. Figure, a flowchart diagram showing the funnel of SQL execution. At the top, a wide funnel labeled raw data table, from. The next stage down is a sieve or filter labeled filtering, where, catching unwanted data rows. The next stage is a sorter labeled sorting, order by, arranging the items. The final output at the bottom is a neat stack of specific data blocks labeled final output, select. The style should be flat vector art, using cool blues and greens. Section 5.5, Common SQL errors and how to debug them efficiently. I have been writing SQL for years, and I still make mistakes almost every day. Coding is not about being perfect, it is about being resilient. When you run a query and see a bright red error bar in BigQuery, do not panic. Read the message. BigQuery is actually very helpful. It usually points to the exact line number where the confusion lies. The most common error for beginners is the trailing comma. Select. Customer underscore name. Purchase underscore amount. This comma is a problem. From. Customer underscore data dot purchase underscore history. In SQL, you put a comma between items in a list, but never after the last item. Think of it like a sentence, you wouldn't put a comma before the period. If you leave a comma after the last column name before the from keyword, the database expects another column and gets confused when it sees from instead. Another frequent issue is string formatting. If you are filtering for text, you must use single or double quotes. Where city equals New York is correct. Where city equals New York will fail because the database thinks New York is a column name, not a specific text value. Finally, watch out for spelling. Computers are literal. If the column is named purchase underscore AMT and you type purchase underscore amount, the query will fail. The database cannot guess your intent. It only knows what is explicitly defined in the schema. Debugging is the process of eliminating these errors. When a query fails, isolate the problem. Comment out lines of code, using in front of the line, to run small pieces of the query one by one. Treat it like a puzzle, not a test of your intelligence. Every error message is just a clue guiding you toward the solution.
Chapter 6, Data Transformation, Advanced SQL for Analysis. Sections, Section 6.1, The Power of Joins, Connecting disparate tables, Section 6.2, Aggregating data with Group BY and having clauses, Section 6.3, Data cleaning within SQL, cast, trim, and coalesce, Section 6.4, Using temporary tables and subqueries for complex problems, Section 6.5, Optimizing query performance for speed and cost. In Chapter 5, we opened the door to the database. You learned how to retrieve data, sort it, and perform basic filtering. You moved from the manual labor of spreadsheets to the heavy machinery of code. But if select asterisk is all you know, you are merely looking through a keyhole. Real-world analysis rarely involves a single, clean table containing every answer. In the professional landscape of 2026, data is fragmented. Customer demographics live in one system, transaction logs in another, and marketing clicks in a third. Your value as an analyst is defined by your ability to weave these disparate threads into a coherent tapestry. This is the process of data transformation. It is the bridge between raw storage and actionable insight. In this chapter, we stop simply asking the database to show us things. Instead, we command the database to build new structures, clean messy inputs on the fly, and connect the dots between isolated datasets. We are moving from reading the language to writing the poetry. This is where the magic happens, and frankly, it is where the fun begins. 6.1 The power of joins, connecting disparate tables. Imagine you are investigating a sales trend. You have a list of order IDs and the total amount spent, but you don't know who made the purchase or where they live. That information is locked away in a separate customers table. To solve this, you need to merge these worlds. In SQL, we use the join clause to connect tables based on a common identifier, a primary key in one table and a foreign key in another. This concept often intimidates beginners, but it is intuitive if you visualize it as a zipper. You are lining up two fabrics, tables, and interlocking them where the teeth, keys, match. Figure, photorealistic educational 3D illustration of two distinct database tables represented as floating glass panes with holographic data rows. A glowing beam of light connects a customer ID column in the left pane to a customer ID column in the right pane, pulling them together to form a combined, wider third pane in the center. The style is cyber minimalist, blue and amber lighting, clean composition. The two most critical types of joins you will use daily are the inner join and the left join. Understanding the difference between these two is often the deciding factor in technical interviews. An inner join is strict. It only returns rows when there is a match in both tables. If a customer exists but hasn't made an order, they vanish from the results. If an order exists but the customer ID is missing, that order is ignored. Select orders.order_ID, orders.amount, customers.customer_name. From orders. Inner join customers. ON orders.customer_ID equals customers.customer_ID. A left join, however, is inclusive. It keeps every row from the left table, the first one you mention, and brings in matching data from the right table. If there is no match, SQL doesn't hide the row, it simply fills the missing details with null. I generally recommend starting with left join when you are exploring data. It is safer because it preserves your primary dataset. You want to see all your orders, even the broken ones with missing customer links, because those broken links might be the very problem you need to solve. 6.2 Aggregating data with Group BY and having clauses. Granular data is essential for investigation, but leadership teams don't want to see a million rows of individual coffee sales. They want to know which store sold the most coffee on Tuesdays. To answer this, we must condense information. The Group BY clause is your summarization tool. It tells SQL to squash rows together based on the columns you specify, while performing math aggregations on the others. Common aggregations include count, sum, average, minute, and max. When you write a query using these, you are essentially creating a pivot table using code. Select store_location. Count order_ID as total_orders. Average, order underscore total, as average underscore spend. From sales underscore data. Group BY store underscore location. However, a common stumbling block arises when you want to filter these results. Beginners often try to use the where clause to filter aggregated data, only to be met with an error message. Here is the golden rule, where filters rows before they are grouped. Having filters groups after they have been aggregated. If you want to look at sales only from 2026, use where. If you want to see only stores that sold more than $10,000 total, you must use having. Select store underscore location. Sum, sales underscore amount, as total underscore revenue. From sales underscore data. Where year equals 2026 filters raw rows first. Group BY store underscore location. Having sum, sales underscore amount, greater than 10,000, filters the resulting groups. Think of where as the bouncer at the door, deciding who gets into the club. Having is the VIP manager inside, deciding which groups get the best tables. 6.3 Data cleaning within SQL, cast, trim, and coalesce. In Chapter 4, we clean data in spreadsheets. But when you are dealing with 50 million rows, you cannot export to Excel to fix a typo. You must clean the data where it lives, inside the query. Data rarely arrives in a perfect format. Numbers might be stored as text strings, preventing you from doing math. Extra spaces might make New York look different from New York. Null values might break your calculations. The cast function is your translator. It forces data from one type to another. If your revenue column is stored as text, e.g., 100.00, cast, revenue as float 64, makes it a number you can sum. The trim function is your sanitizer. It removes leading and trailing white space that the human eye often misses but computers hate. I make it a habit to wrap string columns in trim whenever I am joining tables, just to be safe. Select trim product underscore name, as clean underscore name. Cast, price underscore string as float 64, as price underscore number. From raw underscore inventory. Then there is coalesce, one of my absolute favorite functions. It creates a safety net for missing data. It checks a list of values and returns the first non-null result. If you are calculating a total but some rows have null instead of 0, your math will break. Coalesce, column underscore name, 0, tells SQL, look at this column, if it's empty, pretend it's a 0. 6 point for using temporary tables and subqueries for complex problems. Figure, conceptual infographic style illustration showing a data funnel. At the top, messy blocks labeled null, text, and strings enter. Inside the funnel, icons representing gears labeled coalesce, trim, and cast process the blocks. At the bottom, clean, polished, uniform geometric shapes emerge. White background, vibrant distinct colors for the operations. As your questions get more complex, your queries will get longer. You might need to calculate the average sales per customer, and then, in the same analysis, find customers who are 20% above that average. You cannot do this in a single pass. You have two main options for breaking down complex logic, subqueries and common table expressions, CTEs. A subquery is a query nested inside another query, usually within parentheses. It works, but it can be hard to read, like a sentence with too many commas. I strongly encourage you to embrace CTEs, using the with clause. CTEs allow you to define a temporary result set at the top of your code, name it, and then query it later. It turns your code into a readable story. With regional underscore sales AS. Select region. Sum, sales, as total underscore sales. From orders. Group BY region. Select region. Total underscore sales. From regional underscore sales. Where total underscore sales greater than 100,000. This approach is modular. If the logic for regional_sales changes, you fix it in one place. It keeps your code organized and prevents the mental fatigue of trying to decipher deeply nested logic. 6.5 Optimizing query performance for speed and cost. In a bootcamp environment, your datasets are usually small and free. In the corporate world, queries cost money. Platforms like Google BigQuery charge based on the amount of data processed. A poorly written query can literally cost your employer hundreds of dollars in a few seconds. Optimization is about respect for your time, your colleagues' time, and the company's resources. The first rule of optimization: never run select asterisk on a massive production table. It scans every column, even the ones you don't need. Always name the specific columns you want. The second rule: filter early. Use your where clause as soon as possible. If you only need data from last month, filter for that date before you join it to another massive table. Reducing the dataset size early speeds up every subsequent step. Finally, avoid using distinct unless absolutely necessary. It requires the database to sort and compare every single row to remove duplicates, which is computationally expensive. If you are using distinct to fix a join that created duplicates, you are treating the symptom, not the disease. Fix the join logic instead. Writing efficient SQL is a hallmark of a senior analyst. It shows that you understand what is happening under the hood, not just typing commands until something works.
Chapter 7: Uncovering Insights, Statistical Thinking and Analysis. Sections: Section 7.1, The Analyze Phase, Transitioning from Processing to Interpreting. Section 7.2, Sorting Fact from Fiction, Correlation versus Causation. Section 7.3, Descriptive Statistics, Mean, Median, Mode, and Variance. Section 7.4, Verification Strategies, Stress Testing Your Conclusions. Section 7.5, Using Spreadsheets and SQL Together for Deep Analysis. In Chapter 6, you mastered the heavy machinery of SQL. You learned to join tables, filter complex datasets, and transform raw logs into structured information. You have successfully gathered your evidence and organized it neatly on the table. Now, you must figure out what that evidence actually means. Welcome to the analyze phase of the data lifecycle. This is the moment where technical skill recedes slightly to make room for critical thinking. Up until now, we have focused on the how to write a query, how to clean a cell, how to structure a database. This chapter shifts the focus to the why. A spreadsheet full of perfectly clean numbers is useless if it doesn't tell a story or solve the problem we defined back in Chapter 2. We are moving from being data mechanics to being data detectives. This transition can feel intimidating because there is no single correct line of code to type. Analysis requires intuition, skepticism, and a grasp of statistical reality. But don't worry, you don't need a PhD in mathematics to find truth in data. You just need to learn how to think like an analyst. 7.1 The Analyze Phase, Transitioning from Processing to Interpreting. The process phase was about accuracy and hygiene. The analyze phase is about curiosity and patterns. Your goal here is to identify trends, relationships, and anomalies that answer the business questions you established at the start of the project. Think of it like an archaeological dig. In the previous phases, you cleared away the dirt, cleaning, and arranged the artifacts, processing. Now, you have to look at those artifacts and deduce how the civilization lived. In the professional world, this often looks like an iterative loop. You might spot a trend in sales data, realize you need more granularity, go back to SQL to adjust your query, and then return to your analysis. It is rarely a straight line. Figure: high-contrast infographic illustration showing a cyclical workflow loop. On the left, a SQL editor icon feeds data into a spreadsheet calculation icon on the right. Arrows cycle back and forth, labeled Refine Query and Check Pattern. A magnifying glass hovers over the intersection, symbolizing the insight moment. The style is clean, modern, and corporate tech blue and white. Don't be afraid to get messy here. Analysis is where you play with the data. You pivot it, chart it, break it, and put it back together. You are looking for the signal amidst the noise. However, as you begin finding patterns, you must be vigilant. The human brain is hardwired to find connections even where none exist. This brings us to the most fundamental rule of data analysis. 7.2 Sorting fact from fiction, correlation versus causation. If there is one phrase you remember from this entire certification bootcamp, let it be this: correlation does not imply causation. Correlation means two variables move in the same direction at the same time. Causation means one variable actually causes the other to move. Confusing the two is the quickest way to ruin your credibility as an analyst. Imagine you are analyzing data for a summer resort. You notice two strong trends: ice cream sales are going up, and the number of people getting sunburned is going up. A perfect positive correlation. If you confuse correlation with causation, you might recommend banning ice cream to reduce sunburns. That is obviously absurd. The hidden variable causing both is the sun. In business, these traps are more subtle. You might see that whenever your company sends more emails, revenue drops. You might conclude, emails hurt sales. But perhaps you only send more emails when sales are already slumping to try and boost them. Figure, a split panel vector illustration. The left panel shows a line graph with two lines rising together, labeled ice cream sales and sunburns. The right panel shows a causal diagram revealing a sun icon, the hidden variable, with arrows pointing to both the ice cream and the sunburns, explaining the true cause. Use a flat design style with clear typography. To separate fact from fiction, ask yourself, is there a third factor driving both of these? Be skeptical of your own discoveries. If two things seem connected, prove it. This skepticism is your shield. When you present findings to stakeholders, they will ask, are you sure X caused Y? You need to be ready to say, the data shows a correlation, but we need to test further to prove causation. 7.3 Descriptive statistics, mean, median, mode, and variance. You cannot analyze millions of rows of data by reading them one by one. You need to summarize them. This is the realm of descriptive statistics, using simple numbers to describe the shape of your data. The most common metric is the mean, the average. It is useful, but it is also dangerous. The average is easily distorted by outliers. Consider a small coffee shop. The average yearly income of the 5 customers inside is $50,000. Suddenly, a tech billionaire walks in. The average income in the shop just jumped to $200 million. Does that number accurately represent the people in the shop? Absolutely not. This is where the median comes in. The median is the middle value when the data is sorted. In our coffee shop example, the median income stays around $50,000, regardless of the billionaire. When analyzing salaries, housing prices, or any data with extreme outliers, trust the median over the mean. The mode is simply the most frequent value. This is useful for categorical data. If you are analyzing shoe sales, the average shoe size might be 8.4, which doesn't exist. The mode tells you that size 9 sold the most units. Finally, we have variance and standard deviation. These measure the spread. If the average daily temperature is 70 degrees Fahrenheit, that sounds pleasant. But if the temperature swings from 20 degrees Fahrenheit at night to 120 degrees Fahrenheit at noon, the average hides a chaotic reality. Standard deviation tells you how consistent the data is. 7.4 Verification strategies, stress testing your conclusions. Figure, a clean, educational statistical diagram showing 3 bell curves. The first is a normal distribution, mean equals median. The second is a right-skewed distribution where a few high values pull the mean to the right, leaving the median behind. Visual annotations highlight the gap between mean and median to illustrate the effect of outliers. Background is white, lines are bold, distinct colors. Once you find an interesting insight, perhaps that sales peak on Tuesdays or that a specific marketing campaign failed, do not celebrate yet. You must try to break your own conclusion. We call this sanity checking. The first step is to check for technical errors. Did a join in your SQL query duplicate rows? Did you accidentally filter out a specific region? I once saw an analyst report a 500% growth in user signups overnight. The stakeholders were thrilled. Upon closer inspection, we realized the logging system had broken and was recording every sign-up 5 times. The insight was a mirage caused by dirty data. Ask yourself the "does this make sense?" question. If your data says the average customer age is 150, or that you sold negative units of inventory, stop. The math might be right, but the logic is wrong. Another strategy is to look for the nulls. Did you exclude rows with missing data? If 20% of your customer records are missing the country field, and you ignore them, your geographic analysis is fundamentally biased. Always play the devil's advocate. If you don't find the holes in your analysis, your stakeholders will. It is much better to catch a mistake privately than to explain it publicly. Figure, a conceptual illustration of a data stress test. A magnifying glass focuses on a bar chart where one bar is suspiciously high. Overlay icons show a checklist: check duplicates, verify nulls, validate date range. The overall tone is one of scrutiny and quality assurance. 7.5 Using spreadsheets and SQL together for deep analysis. In chapters 4 and 5, we treated spreadsheets and SQL as separate tools. In the real world of 2026, they are best friends. They work in tandem to deliver the best results. SQL is your heavy lifter. It grabs the raw data, aggregates it, filters it, and shrinks it down from 10 million rows to a manageable summary table. Spreadsheets are your visual explorer. Once SQL has done the heavy lifting, you export that summary to a spreadsheet to create pivot tables, conditional formatting, and quick charts. Here is a typical workflow. Imagine you want to analyze sales by category for the last year. First, use SQL to aggregate the data. Select category, count, order_ID, as total_orders. Sum, sales_amount, as total_revenue. Average, sales_amount, as average_order_value. From sales_data. Where order_date between the 1st of January, 2025 and the 31st of December, 2025. Group by category. Order by total_revenue desk. This query transforms a massive database into a small, readable table. You don't analyze this text output, though. You export these results to a spreadsheet. Once in the spreadsheet, you can instantly calculate profit margins, create a bar chart to visualize revenue differences, or use conditional formatting to highlight categories that are underperforming. By combining the processing power of SQL with the flexibility of spreadsheets, you get the best of both worlds. You save time, avoid software crashes, and keep your analysis agile. We have now processed the data and uncovered the insights. We know what the numbers are saying. But numbers alone rarely change minds. In the next chapter, we will learn how to turn these statistical findings into compelling visuals that drive action.
Chapter 8, Visual Storytelling, Principles of Effective Design. Sections, Section 8.1, The Psychology of Visualization, How Humans Perceive Data, Section 8.2, Selecting the Right Chart Type for Your Narrative, Section 8.3, Decluttering, Removing Noise to Highlight the Signal, Section 8.4, Color Theory and Accessibility, Designing for Every Viewer, Section 8.5, Ethical Visualization, Avoiding Misleading Scales and Distortions. In Chapter 7, we navigated the complex waters of statistical analysis. You learned to distinguish between correlation and causation, and you uncovered the hidden truths buried within your datasets. You now hold the answers to the questions we asked back in Chapter 2. However, having the answer is only half the battle. If you cannot communicate that answer to your stakeholders, busy executives, non-technical managers, or skeptical clients, your analysis effectively does not exist. This brings us to the share phase of the data analysis life cycle. Data visualization is often mistaken for making things look pretty. That is a dangerous misconception. Design is not decoration, design is communication. It is the bridge between your spreadsheet logic and human understanding. In this chapter, we will transition from being analysts to being storytellers. We will explore how the human brain processes visual information and how you can leverage that biology to make your insights impossible to ignore. 8.1 The Psychology of Visualization: How Humans Perceive Data. To design effective visuals, you must first understand the machinery of the human mind. Our brains are not wired to process rows and columns of numbers. We are evolved to detect patterns, contrast, and movement in our environment to survive. When a stakeholder looks at a dashboard, their brain engages in pre-attentive processing. This happens in milliseconds, long before they consciously read the title of your chart. They notice color differences, size variations, and spatial groupings instantly. Your job is to exploit these pre-attentive attributes to guide the viewer's eye. If you create a chart where everything is the same color and size, the brain has to work hard to find the meaning. If you highlight the key insight in a bold color, the brain finds it automatically. Figure: extra detailed AI-ready prompt for AI-generated diagram showing the concept of pre-attentive attributes. The image should be split into two panels. The left panel shows a chaotic grid of gray numbers with no pattern. The right panel shows the same grid, but the number 7 is highlighted in bright red and bolded throughout, making the pattern instantly visible. The style should be clean, minimalist vector art with a white background, emphasizing the contrast between cognitive load and pre-attentive processing. The dot. We also rely heavily on Gestalt principles, particularly the principles of proximity and similarity. We naturally group objects that are close together or look alike. If your bar chart places related metrics far apart, you are fighting against the viewer's biology. Effective design minimizes cognitive load. You want your audience to spend their mental energy understanding the insight, not figuring out how to read the chart. Every unnecessary grid line or label adds friction to that process. 8.2 Selecting the right chart type for your narrative. The most common mistake I see in certification portfolios is the misuse of chart types. Beginners often choose a chart because it looks impressive or complex, rather than because it is the best tool for the job. Form must always follow function. Before you click a button in Tableau or Excel, ask yourself, what relationship am I trying to show? Are you comparing values, showing a trend over time, illustrating a part-to-whole relationship, or analyzing a distribution? If you are comparing categories, like sales by region, a bar chart is almost always superior to a column chart because horizontal text is easier to read. If you are showing trends over time, a line chart is the standard for a reason. Our eyes naturally follow the left-to-right progression as a narrative. Avoid the temptation of the pie chart. While popular in marketing, they are notoriously difficult for the human eye to read accurately. We struggle to compare angles and surface areas. If you have more than 3 slices, switch to a bar chart. The following table serves as your compass for selecting the right visual. Goal of analysis: recommended chart type. Why it works. Choose the simplest chart that tells the truth. If your reader needs a paragraph of text to understand how to read the visual, you have likely chosen the wrong format. 8.3 Decluttering: removing noise to highlight the signal. Edward Tufte, a pioneer in data visualization, coined the term data ink ratio. It proposes that every drop of ink on a page, or pixel on a screen, should be devoted to displaying the data itself. Anything else is noise. Default chart settings in most software are full of noise. They include heavy grid lines, dark borders, redundant axis labels, and 3D effects. These elements clutter the visual field and compete for attention with your actual data points. Decluttering is an act of subtraction. Start by removing the border around the chart. Then, lighten or remove the grid lines. If you label the data points directly, you often don't need an axis at all. Consider the labels. You do not need a legend if you can place the label directly next to the line or bar. Forcing the reader to look back and forth between the chart and a legend box creates visual ping-pong, which breaks their concentration. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a before and after of a bar chart. The before side is a cluttered, 3D bar chart with heavy grid lines, a dark background, a legend, and redundant axis labels. The afterside is a sleek, 2D flat design with a white background, no grid lines, direct labeling on the bars, and a clear title. The lighting should be neutral, highlighting the clarity of the second version. Your goal is to strip the visual down to its essence. When you remove the clutter, the data stands out. The signal becomes stronger because the noise is gone. 8-point for color theory and accessibility, designing for every viewer. Color is a functional tool, not an artistic choice. In data analytics, color has two primary jobs: to categorize separate groups or to highlight specific data points. It should never be used randomly. A common pitfall is using a distinct color for every single bar in a bar chart. If the bars represent the same metric, e.g., revenue, they should all be the same color. Use a second color only to highlight a specific bar, such as our company versus competitors. You must also design for accessibility. Approximately 1 in 12 men and 1 in 200 women possess some form of color vision deficiency, CVD. A chart that relies solely on red and green to distinguish between good and bad will be unintelligible to many viewers. Use colorblind safe palettes, like blue and orange, and double encode your data. Double encoding means using a secondary visual cue, like a symbol or a pattern, alongside color to indicate meaning. This ensures everyone receives the message. Contrast is equally important. Ensure your text stands out sharply against the background. Gray text on a white background might look sleek, but if it is too light, it becomes unreadable on a projector or a mobile screen. 8.5 Ethical visualization, avoiding misleading scales and distortions. We discussed data ethics in Chapter 3 regarding privacy and consent. Now, we must address ethical presentation. It is dangerously easy to lie with charts, and doing so will destroy your credibility as an analyst. The most common ethical violation is truncating the y-axis. This happens when a bar chart starts the vertical axis at a number other than 0. By starting the axis at 50, a small difference between 52 and 55 looks massive visually. This distorts reality to create a sensationalized narrative. Bar charts must always start at 0. Line charts have more flexibility since they show trends, but you must clearly label the axis limits to avoid misleading the viewer. Be wary of cherry-picking timeframes. Showing a sales increase over the last 3 months while ignoring the steady decline of the previous 2 years is a form of deception. You must show the full context, even when the data contradicts the story your stakeholders want to hear. Figure, extra detailed AI-ready prompt for AI-generated diagram illustrating the lie factor. The image shows 2 side-by-side bar charts displaying the same data. The left chart has a truncated axis starting at 95, making a 2% difference look huge. The right chart has a 0 baseline, showing the difference is actually negligible. A red caution icon hovers over the left chart, and a green checkmark over the right. The style is instructional and schematic. As a data professional, you are the guardian of the truth. Your visualization should reveal the data as it is, not as someone wishes it to be. Integrity is the currency of your career, do not spend it on a misleading chart. In this chapter, we have covered the principles that turn raw output into compelling stories. We looked at how the brain sees, how to choose the right tools, and how to design with clarity and integrity. You are now ready to take your cleaned, analyzed data and present it to the world.
Chapter 9, Dashboard Dynamics, Getting Started with Tableau. Sections, Section 9.1, the Tableau Interface, Connecting Sources and Managing Worksheets, Section 9.2, Dimensions versus Measures, Understanding Continuous and Discrete Fields, Section 9.3, Building Core Visualizations, Bar Charts, Line Graphs, and Heat Maps, Section 9.4, Enhancing Visuals with Filters, Marks, and Tooltips, Section 9.5, Geographic Data, Mapping Trends Across Locations. In Chapter 8, we studied the philosophy of design. You learned that effective visualization is not about making charts pretty, but about making data intelligible. We discussed color theory, cognitive load, and the ethical responsibility of the analyst to present the truth without distortion. Now, it is time to pick up your brush. While spreadsheets are excellent for row-level analysis and SQL is the king of data retrieval, neither is built for dynamic, interactive storytelling. To bridge the gap between raw numbers and executive decision-making, we need a dedicated business intelligence (BI) tool. In the modern landscape of 2026, Tableau remains the industry standard for its flexibility and power. Opening Tableau for the first time can feel like sitting in the cockpit of a jet. There are shelves, cards, and distinct panes that look nothing like the familiar grid of a spreadsheet. Do not be intimidated by the blank canvas. By the end of this chapter, you will understand the mechanics of this interface. You will learn how to connect to your data, distinguish between different field types, and construct the core visualizations that form the backbone of professional analytics. Let's turn your data into a dashboard. 9.1 The Tableau Interface, Connecting Sources and Managing Worksheets. The first step in any Tableau project is establishing a connection. Unlike a spreadsheet where the data lives in the file, Tableau usually acts as a window into data that lives elsewhere, be it a SQL server, a cloud database, or a CSV file on your desktop. This distinction is vital because it means your visualizations can update automatically as the underlying data changes. When you launch the application, you land on the Connect pane. Here, you will select your data source. Once connected, you enter the data source page, which functions remarkably like the SQL joins we practiced in Chapter 6. You can drag multiple tables onto the canvas and define how they relate to one another. Figure, a high-fidelity diagram of the Tableau data source interface. The left pane lists file types, Excel, text, JSON, and server options. The central canvas shows two tables joined by a Venn diagram icon, inner join. The bottom half displays a data preview grid with clear headers and data types indicated by small icons, calendar for date, globe for geography, hash for numbers. Lighting is clean, UI focuses on high contrast for readability. Once your data is prepared, you move to the main workspace, the worksheet. This is your studio. The interface is divided into key areas, the data pane on the left, the shelves, columns and rows, at the top, and the canvas in the center. Think of the columns and rows shelves as your X and Y axes. If you drag a field to columns, you are spreading data horizontally, drag it to rows, and you stack it vertically. This tactile drag-and-drop experience is what makes Tableau so intuitive for exploration. You aren't writing code to see a chart, you are physically moving data to see how it looks. At the bottom of the window, you will see tabs similar to a spreadsheet. However, in Tableau, a tab can be a worksheet, a single chart, a dashboard, a collection of charts, or a story, a narrative sequence. We will focus primarily on worksheets in this chapter, as they are the building blocks of everything else. 9.2 Dimensions versus Measures, Understanding Continuous and Discrete Fields. If you take only one concept away from this chapter, let it be this one. The distinction between dimensions and measures, and the related concept of discrete versus continuous fields, governs how Tableau behaves. If you misunderstand this, the tool will seem to fight you at every turn. When you load data, Tableau automatically sorts your fields into two sections in the data pane. Asterisk dimensions, usually blue icons, are qualitative data. They describe the who, what, and where names, dates, and geographical locations. Asterisk measures, usually green icons, are quantitative data. They describe the how much, sales, profit, quantities, and temperature. Here is the functional difference. Dimensions slice the data, measures are aggregated. If you drag a region, dimension, to the canvas, Tableau creates a header for each region. If you drag sales, measure, to the canvas, Tableau does math, usually summing the sales into a single number. Figure, a split-screen educational diagram comparing dimensions and measures. On the left, dimensions, a blue puzzle piece labeled category breaks a bar chart into three distinct colored bars. On the right, measures, a green ruler icon labeled profit extends the length of a single bar. The background is a subtle grid, emphasizing the structural versus mathematical difference. Closely tied to this is the color coding of the pills, the fields you drag. Asterisk blue pills, discrete these create headers and distinct buckets. Think of distinct categories like furniture, office supplies, and technology. Asterisk green pills, continuous. These create axes. Think of a timeline or a measuring tape where values flow continuously from low to high. A common point of confusion for beginners is that dates can be both. A year can be a discrete header, 2024, 2025, 2026, creating three distinct buckets. Alternatively, a date can be continuous, plotting a trend line that flows smoothly through time. Learning to toggle between these states gives you immense control over your visualization. 9.3 Building core visualizations, bar charts, line graphs, and heat maps. Now that we understand the ingredients, let's start cooking. We will focus on the three most common chart types you will use in a professional setting. While Tableau has a Show Me tab that can auto-generate charts, I encourage you to build them manually to understand the mechanics. The bar chart. Bar charts are the gold standard for comparing categories. To build one, simply drag a dimension, like category, to the rows shelf and a measure, like sales, to the columns shelf. Tableau immediately generates bars proportional to the sales volume. To make this insight useful, you should almost always sort the data. A button on the toolbar allows you to sort descending or ascending. A sorted bar chart instantly answers the question, which category is performing best, without forcing the viewer to do mental gymnastics. The line graph. Line graphs are essential for time series analysis. Drag a date field to the columns shelf and a measure to the rows shelf. By default, Tableau might aggregate this by year. Here is where the interactive magic happens. You can click the plus symbol on the date pill to drill down from year to quarter, to month, and even to day. This hierarchy allows you to spot seasonal trends like a holiday spike that might be hidden in the annual aggregate. The heat map. Sometimes, you need to see the relationship between two dimensions and a measure. For example, which product category is most profitable across different regions? Drag region to columns and category to rows. You now have a text table. To turn this into a heat map, drag profit onto the color square in the marks card, more on this shortly. Suddenly, the highest numbers turn dark blue and the losses turn red-orange, allowing patterns to pop out instantly. 9.4 Enhancing visuals with filters, marks, and tooltips. Figure, a composite visual showing three chart types. Left, a sorted horizontal bar chart with teal bars. Center, a jagged line graph showing an upward trend with a seasonal dip. Right, a density heat map using a blue to orange divergent scale. Each chart has a clear, minimalist title and axis labels, demonstrating clean design principles. A basic chart displays data, an enhanced chart communicates meaning. The marks card is the artistic control center of Tableau. It allows you to encode data using color, size, label, and detail. For instance, in a scatter plot comparing sales versus profit, you have dots everywhere. By dragging region onto the color mark, you instantly differentiate the dots by geography. By dragging discount onto the size mark, the dots grow or shrink based on how much the product was discounted. Filters are your tool for focusing the narrative. You can drag any field into the filters shelf to include or exclude data. In 2026, interactivity is expected. You can right-click a filter and select Show Filter to give your end user a drop-down menu, letting them explore the data themselves. Finally, never neglect the tooltip. This is the box that appears when you hover over a data point. By default, Tableau lists the basic fields. However, you can click the tooltip button on the marks card to write a sentence. Instead of just showing region, West, sales, 5,000, you can customize it to read, the West region generated $5,000 in sales. This small touch humanizes the data and makes your dashboard significantly more accessible to non-technical stakeholders. 9.5 Geographic data, mapping trends across locations. Tableau possesses an uncanny ability to recognize geographic data. If your dataset contains columns named city, state, country, or zip code, Tableau automatically assigns them geographic roles and generates latitude and longitude fields. To create a map, you simply double-click a geographic field. Tableau will place a dot on the canvas for every location in your dataset. But a map with dots tells us very little. We need to encode meaning into those locations. There are two primary ways to do this. 1. Symbol maps. Drag a measure, like sales, to size. Now, New York City appears as a large bubble, while a smaller town appears as a tiny dot. 2. Filled maps. Choropleth change the mark type to map and drag a measure to color. This fills the shape of the state or country with a color gradient representing the data intensity. Figure. A vibrant filled map of the United States. States are colored in shades of purple based on sales volume. A specific state, California, is hovered over, displaying a custom tooltip box with clear typography reading California, $45 million revenue. The map background is neutral gray to make the data colors pop. Maps are powerful, but use them with caution. As we discussed in Chapter 8, maps can be misleading if the land area doesn't correlate to the data importance. A large state like Montana might dominate the visual simply because it is big, even if its sales are low compared to a physically smaller state like Massachusetts. Always ensure your map adds genuine analytical value, rather than just visual variety. Conclusion. You have now toured the cockpit. You understand how to connect data, the crucial difference between blue and green pills, and how to construct the primary visualizations that drive business intelligence. This phase of learning requires patience. You will drag a pill to the wrong shelf. You will accidentally turn a bar chart into a scattering of unintelligible shapes. This is not failure, this is how you learn the syntax of the tool. In the next chapter, we will take these individual worksheets and assemble them. We will move from creating static images to building fully interactive dashboards and stories that allow users to drill down into the data themselves. The share phase is just beginning.
Chapter 10, the share phase, crafting compelling dashboards. Sections, Section 10.1, Assembling the narrative, moving from individual sheets to dashboards, Section 10.2, Creating interactivity with dashboard actions and parameters, Section 10.3, Calculated fields, customizing data for deeper insights, Section 10.4, Presentation skills, delivering your findings to non-technical audiences, Section 10.5, Publishing and maintaining your Tableau public profile. In Chapter 9, we opened the toolbox of Tableau. You connected to data, navigated the interface, and built your first individual visualizations. You saw how quickly a spreadsheet of raw numbers could become a bar chart or a geographic map. But right now, those visualizations are like loose pages of a manuscript scattered on a desk. Individually, a single chart can answer a specific question. However, real-world business problems are rarely simple enough to be solved by one graph. Stakeholders need context, they need relationships, and they need to see the bigger picture. This brings us to the share phase of the data analysis life cycle. This is where you transition from an analyst to a storyteller. In this chapter, we will combine your isolated worksheets into a cohesive, interactive dashboard. We will script the logic that allows users to explore the data themselves, and we will discuss how to stand up in a room, or a Zoom call, and deliver your findings with confidence. 10.1 Assembling the narrative, moving from individual sheets to dashboards. A dashboard is not just a collection of charts plastered onto a single screen. If you simply drag every worksheet you have created onto the canvas, you create visual noise, not insight. A dashboard is a curated display of related information, designed to achieve a specific objective. Think of your dashboard like a car's dashboard. It doesn't show you every single mechanical metric the engine produces. It shows you speed, fuel, and engine temperature, the things you need to drive safely. Your job is to curate your data visuals with the same level of intention. When you click the New Dashboard tab in Tableau, you are presented with a blank canvas and two primary ways to arrange your objects, tiled and floating. Tiled versus floating layouts. The distinction between these two modes is often the difference between a professional-looking product and a messy one. Tiled layouts snap objects into a grid. When you drag a sheet onto the canvas, it fills the available space. As you add more sheets, they divide the space mathematically. This ensures alignment and consistency. For 90% of business reporting, tiled is your best friend. It ensures that your dashboard resizes gracefully on different screen sizes. Floating layouts allow you to place objects anywhere, pixel perfect, on top of other objects. This offers creative freedom but introduces risk. Floating elements can shift unexpectedly or cover important data if the screen resolution changes. The hierarchy of containers. Figure, a side-by-side comparison diagram of a Tableau dashboard workspace. On the left, a tiled layout shows 3 charts locked into a neat grid structure with blue highlighting indicating the snap zones. On the right, a floating layout shows charts overlapping slightly with loose positioning. Arrows indicate the object's pane where the tiled, floating toggle is located. The style is clean, semi-technical UI wireframe. To master the tiled layout, you must understand layout containers. These are invisible boxes that hold your charts. Vertical containers stack objects on top of each other. Horizontal containers place objects side by side. By nesting these containers, you build a rigid structure that holds your narrative together. I recommend sketching your layout on a piece of paper before you even touch the mouse. Know where your hero chart, the most important visual, goes, usually the top left, following the F pattern of reading, and where your supporting context belongs. 10.2 Creating interactivity with dashboard actions and parameters. A static image is a dead end. If a manager sees a spike in sales in the West region, their immediate instinct is to ask, why? In a PowerPoint slide, you have to anticipate that question. In Tableau, you let the user click the West bar to find out for themselves. This is achieved through dashboard actions. Filters and highlights. The most common interactivity is the filter action. You can configure your dashboard so that clicking a specific data point on one chart automatically filters every other chart on the screen to focus on that selection. For example, imagine a dashboard with a map of the US and a list of product categories. By setting the map as a filter, clicking California instantly shrinks the product list to show only sales in California. To set this up quickly, look for the funnel icon on the border of your selected worksheet on the dashboard. It's a small button, but it unlocks the use as filter capability instantly. Parameters, the remote control of data. While filters reduce data, parameters change the data itself. A parameter is a variable, a placeholder that waits for input from the user. Imagine you are analyzing top N customers. Instead of hard-coding the top 10, you can create a parameter that lets the user type in a number or use a slider. They can look at the top 5, top 20, or top 50 without you needing to rebuild the chart. Here is the logic flow for a parameter. 1. Create the parameter, define the data type, e.g., integer, and allowable values, e.g., range 1 to 100. 2. Create a calculation, write a script that references the parameter. 3. Show the control, expose the slider or drop down to the user. It empowers your stakeholders to ask what-if questions without needing to know SQL or coding. Figure, a close-up user interface mock-up of a Tableau parameter control panel. The main visual shows a top-end customer's slider set to 15. Below it, a drop-down menu labeled Select Metric allows the user to switch between sales, profit, and quantity. A conceptual arrow connects this control panel to a bar chart, illustrating that changing the control changes the chart content. 10.3 Calculated fields, customizing data for deeper insights. Often, as you assemble your dashboard, you will realize the data in your database isn't quite right. You have sales and cost, but you need profit margin. You have a date, but you need to flag weekends. You do not need to go back to SQL to fix this. You can create calculated fields directly in Tableau. This allows you to extend your dataset on the fly. The syntax of analysis. Tableau uses a coding syntax that is very similar to SQL and Excel formulas. If you mastered Chapter 5, this will feel familiar. Let's look at a common scenario, creating a logic flag to highlight unprofitable orders. You want to color code your scatter plot to instantly show which orders lost money. / calculation unprofitable flag. If profit 0 then unprofitable, else profitable. END. Once you create this field, it appears in your data pane just like any other column. You can drag it onto the color mark, and suddenly your scatter plot tells a clear story: red dots for trouble, blue dots for success. Level of detail, LOD, expressions. As you advance, you will encounter the need for LOD expressions. These are powerful calculations that allow you to compute values at a different level of granularity than your visualization. For instance, suppose you want to compare a specific customer's sales against the average sales of the entire region. A standard chart filters data down to the customer. An LOD expression allows you to say, ignore the customer filter for a moment, calculate the regional average, and bring that number back here. / calculation, regional average sales. Fixed, region, average, sales. These calculations are the difference between reporting what happened and explaining why it happened relative to the benchmark. 10-point for presentation skills, delivering your findings to non-technical audiences. You have cleaned the data, built the model, and crafted a beautiful, interactive dashboard. But your job is not done. The share phase concludes with the presentation. I have seen brilliant analysts fail because they assumed the data would speak for itself. It does not. You must be the translator. The 5-second rule. When you project your dashboard onto a screen during a meeting, your audience will spend the first 5 seconds trying to orient themselves. If they cannot understand the primary message within 5 seconds, you have lost them. Use clear titles. Sales by region is okay. West region is underperforming is better. Remove clutter, get rid of grid lines, excessive labels, and decorative borders that add cognitive load. Know your audience. Adjust your narrative based on who is in the room. The executive, they care about the bottom line. Start with the conclusion. We are down 5% year-over-year, primarily due to supply chain issues in the East. Here is the data. The manager, they care about operations. Walk them through the why. Show them which specific products are causing the issue so they can fix it. The peer, they care about the methodology. You can discuss your calculated fields and data sources here, but keep this out of the executive summary. Storytelling versus reporting. Reporting is listing numbers, revenue is $1 million, cost is $800,000. Storytelling is connecting the dots. Although revenue hit $1 million, our costs rose unexpectedly, shrinking our margins. This suggests we need to renegotiate with our vendors. Your dashboard is a prop in this story. Use the interactivity live. When an executive asks a question, click the filter and show them the answer in real time. That creates confidence in your data. 10.5 Publishing and maintaining your Tableau public profile. For those of you seeking to break into the industry or switch careers, this final section is critical. In the creative arts, painters have portfolios. In data analytics, we have Tableau Public. Tableau Public is a free platform where you can publish your dashboards for the world to see. It serves as concrete proof of your skills. A resume says you know data analysis, a Tableau Public profile shows it. Preparing for publication. Before you upload, you must ensure data privacy. Never, ever publish proprietary company data or sensitive personal information, PII, to the public web. Anonymize your data. If you are practicing with real datasets, remove names and addresses. Create an extract. Tableau Public requires data to be extracted, saved within the file, rather than connected live to a database. Mobile optimization. Check how your dashboard looks on a phone layout, accessible via the dashboard pane. Recruiters often check links on their mobile devices. Building your brand. Treat your Tableau Public profile as your professional gallery. * Curate your work, quality over quantity. 3 Polished, insightful dashboards are better than 20 unfinished drafts. Participate in community challenges, look for initiatives like #Makeover Monday or #Workout Wednesday. These are community-driven challenges where everyone works on the same dataset. It is a fantastic way to learn from others and get noticed by hiring managers. Your profile link belongs on your LinkedIn and at the top of your resume. When I interview candidates, I always look at their portfolio before I look at their degree. It tells me how they think, how they design, and how they communicate. In the next chapter, we will step back from the specific tools and look at the broader ecosystem of data governance and ethics, ensuring that the powerful systems you are building are used responsibly.
Chapter 11: Programming Power, Fundamentals of R for Analytics. Sections: Section 11.1, Why Learn R? The Benefits of Scripted Analysis, Section 11.2, Setting up RStudio and Understanding the Console, Section 11.3, R Syntax Basics, Variables, Vectors, and Data Frames, Section 11.4, Installing and Managing Packages from CRAN, Section 11.5, Reading and Inspecting Data Files in the R environment. In Chapter 10, you learned how to present your findings using Tableau. You moved from raw numbers to interactive dashboards, mastering the art of the visual narrative. You now possess the skills to query data with SQL and visualize it with business intelligence tools. But there is a missing piece in our toolkit. Sometimes, SQL is too rigid for complex statistical modeling. Sometimes, Excel buckles under the weight of millions of rows. And sometimes, you need a process that is not just repeatable, but fully automated and documentable down to the slightest calculation. Welcome to the world of programming. For many aspiring analysts, this is the most intimidating threshold. The graphical interfaces of Excel and Tableau feel safe, the blinking cursor of a code editor feels demanding. I want to assure you that this fear is natural, but misplaced. Programming is not about memorizing cryptic encyclopedias of commands. It is simply a way to give the computer a set of instructions. In this chapter, we will introduce R. It is a language built by statisticians, for statisticians. By the end of this chapter, you won't just be a user of software, you will be a creator of analysis. 11.1 Why Learn R? The Benefits of Scripted Analysis. If you are already comfortable with SQL and Tableau, you might ask, why do I need to learn code? The answer lies in one critical concept: reproducibility. Imagine you have just finished a complex analysis in a spreadsheet. You clicked through menus, applied filters, deleted 3 specific outlier rows, and created a pivot table. 6 months later, your stakeholder asks you to run the exact same analysis on new data. Can you remember every single click? Likely not. R solves this problem. When you analyze data in R, you are writing a script, a recipe. This script documents every single step of your logic. If you need to run the analysis again next year, or if a colleague needs to audit your work, the code tells the whole story. Furthermore, R is an absolute powerhouse for statistical computing. While spreadsheets struggle with heavy datasets, R can process millions of rows with speed and precision. It allows you to clean messy data, perform advanced statistical modeling, and create custom visualizations that go far beyond standard chart types. Figure: high-contrast schematic diagram comparing GUI workflow versus scripted workflow. Left side shows a tangled web of mouse cursors and drop-down menus labeled hidden logic. Right side shows a clean, linear flowchart representing code lines labeled transparent logic. The style should be minimalist, blueprint aesthetic with blue and white lines. In the modern data stack of 2026, R is often the glue that holds the analysis together. You might pull data with SQL, model it in R, and visualize the results in Tableau. Learning this language transforms you from a data operator into a data architect. 11.2 Setting up RStudio and Understanding the Console. Before we write code, we need to understand our environment. There is a common point of confusion here: the difference between R and RStudio. Think of R as the engine of a car. It does the heavy lifting, the calculations, and the processing. However, you don't drive a car by sitting directly on the engine. RStudio is the dashboard, the steering wheel, and the windshield. It is an integrated development environment, IDE, that makes working with the R engine comfortable and efficient. You will almost always work inside RStudio. When you open RStudio for the first time, the interface is divided into 4 main quadrants. Understanding these panes is crucial for your navigation. Figure, detailed annotated screenshot of the RStudio interface. The image is divided into 4 quadrants. Top left, source editor, labeled the recipe book. Bottom left, console, labeled the kitchen. Top right, environment history, labeled the pantry. Bottom right, files plots packages, labeled the display window. The lighting should be soft, focusing on the layout structure. Top left, source editor. This is where you write your scripts. Nothing runs here until you tell it to. It is your drafting table. Bottom left, console. This is where the code actually runs. You can type commands directly here for quick math, but usually, you send code here from the source editor. Top right, environment. This shows you what data and variables you currently have loaded in memory. If you load a dataset, it appears here. Bottom right, plots files. This is where your charts appear, and where you manage your files. Let's run your first command. In the console, bottom left, type the following and press enter. Print, hello, data world. The console should return, 1, hello, data world. You have just spoken to the computer, and it spoke back. You are officially programming. 11.3 syntax basics, variables, vectors, and data frames. Our syntax is unique, but it follows a logical structure. The first thing you will notice is the assignment operator. In many languages, you use an equals sign symbol to assign a value. In R, we traditionally use an arrow, dash. Think of as saying save this into that. Variables. A variable is a container for a value. Let's create a variable called sales_total. Sales_total 5,000. If you look at your environment pane, top right, you will see sales_total appear with the value 5,000. You can now use this variable in calculations. Tax_rate 0.08. Final_amount sales_total asterisk 1 plus tax_rate. Print, final_amount. Vectors. Data analysis rarely deals with single numbers, we deal with lists of numbers. In R, these are called vectors. You create a vector using the C function, which stands for combine or concatenate. Creating a vector of monthly sales. Monthly_sales C, 4,500, 5,200, 4,800, 6,100. We can do math on the whole list at once. This is called vectorization, a superpower of R. Monthly_sales_ with tax monthly_sales asterisk 1.08. Notice what happened there. We didn't need a loop or a complex command. We multiplied the vector by a number, and R applied that math to every item in the list automatically. This behavior makes R incredibly fast for data cleaning. Data frames. The data frame is the heart of R for analysts. It is essentially a table, rows and columns, just like you would see in SQL or Excel. A data frame is really just a collection of vectors of the same length pasted together side by side. Creating a simple data frame. Employee_data data.frame. Name equals C, Sarah, Jamal, Wei. Department equals C, sales, marketing, IT. Salary equals C, 65,000, 72,000, 80,000. When you work with datasets in R, you are almost always manipulating data frames. 11.4 Installing and managing packages from CRAN. Base R, the software you installed, comes with many built-in functions. However, the real power of R comes from its community. Developers around the world create bundles of code called packages to solve specific problems. Think of Base R as a brand new smartphone. It works fine out of the box, you can make calls and take photos. But to check your email, navigate traffic, or listen to music, you need to install apps. In R, these apps are packages, and the App Store is called CRAN, Comprehensive R Archive Network. There is a two-step process to using a package. Install it. You only do this once per computer. This is like downloading the app. Load it. You do this every time you start a new R session. This is like tapping the app icon to open it. The most important collection of packages you will use in this bootcamp is called the Tidyverse. It is a suite of tools designed specifically for data science. Step 1. Install the package, only do this once. Install.packages, Tidyverse. Step 2. Load the library, do this at the start of every script. Library, Tidyverse. Figure, illustration of a library bookshelf analogy. On the left, a closed box labeled CRAN. An arrow points to a bookshelf labeled Local Library where a book titled Tidyverse is sitting. A character is shown taking the book off the shelf and opening it on a desk. Caption, install.packages, buys the book, library, opens it for reading. When you run library, Tidyverse, you unlock thousands of powerful functions that make data cleaning and visualization significantly easier than using base R alone. We will rely heavily on this in the coming chapters. 11.5 Reading and inspecting data files in the R environment. We have set the stage, now let's bring in the actors. The first step in any analysis is importing your data. While R can connect directly to SQL databases, as we discussed in Chapter 6, you will frequently work with CSV, comma-separated values, files. Using the reader package, part of the Tidyverse, we can pull data into our environment efficiently. Assuming you have a file named customer_data.csv in your project folder. Customers read_CSV, customer_data.csv. Once the data is loaded, you need to inspect it. In Excel, you would scroll through thousands of rows, but that is inefficient and risky. In R, we use specific functions to get a health check of our data. Here are the 3 commands you should run immediately after loading any dataset. Head, customers. This shows you the first 6 rows. It lets you verify that the data loaded correctly and the headers look right. Col names, customers. This gives you a list of all column names, helping you spot typos or unexpected spacing. Glimpse, customers. This is my favorite. It rotates the data, showing you every column name, the type of data, text, number, date it contains, and the first few values. A quick look at the data structure. Glimpse, customers. The output of Glimpse tells you immediately if your numbers are accidentally stored as text, or if your dates are not recognized as dates. Catching these issues now, before you start your analysis, saves you hours of frustration later. You have now successfully set up your environment, learned the basic grammar of the language, and loaded your first dataset. You are no longer just looking at the data, you have it trapped in your environment, ready to be molded. In the next chapter, we will take this raw data and apply the tidy philosophy. We will learn how to filter, sort, and mutate our data frames to uncover the answers hiding within the rows.
Chapter 12, Scripting Success, Data Wrangling and Visualization in R. Sections, Section 12.1, The Tidyverse Revolution, An Introduction to Tidy Data, Section 12.2, Manipulation Magic, Filtering and Mutating with DPLYR, Section 12.3, Cleaning Pipelines, Handling Missing Values and Dates in R, Section 12.4, Grammar of Graphics, Building Stunning Plots with Plot2, Section 12.5, R Markdown, Weaving Code and Commentary into Professional Reports. In Chapter 11, we broke the seal on programming. You learned the fundamental syntax of R, understanding how to store values in variables and create vectors. You stepped away from the mouse and keyboard shortcuts of Excel and began to speak the language of the machine. But syntax alone does not solve business problems. Knowing how to define a variable is like knowing how to hold a hammer. It is essential, but it doesn't build the house. To truly leverage R in your career, you need to move from basic definitions to active manipulation. In this chapter, we will master the Tidyverse. This collection of packages effectively rewrites R into a human-readable dialect designed specifically for data science. We will learn to wrangle data, cleaning, filtering, and reshaping it to fit our needs. Then, we will return to visualization. Unlike the drag-and-drop interface of Tableau, plotting in R gives you granular control over every pixel. By the end of this chapter, you will not just be running code, you will be building reproducible, professional-grade analysis pipelines that can serve as the backbone of your portfolio. 12.1 The Tidyverse Revolution, an Introduction to Tidy Data. For years, R was a quirky language used mostly by academic statisticians. Then came the Tidyverse, a suite of packages built by Hadley Wickham and others, which standardized how we interact with data. It turned R from a complex statistical engine into an accessible, logical tool for analysts. The core philosophy here is the concept of tidy data. In a tidy data set, every column is a variable, every row is an observation, and every cell contains a single value. It sounds simple, but 80% of your time as an analyst will be spent forcing messy, real-world data into this structure. To get started, we don't load these packages individually. We load the core Tidyverse, which gives us access to dplyr for manipulation, plot2 for visualization, tidyr for cleaning, and more. Install the Tidyverse if you haven't already. Install.packages, Tidyverse. Load the library to access all core packages. Library, Tidyverse. Think of the Tidyverse as a well-organized workshop. Without it, you are rummaging through a junk drawer looking for tools that don't fit together. With it, every tool has a specific purpose and works seamlessly with the others. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the tidy data structure. A 3D isometric view of a data table floating in a clean, white digital space. The columns are highlighted in soft blue glowing light labeled variables, and rows are highlighted in soft orange labeled observations. A magnifying glass focuses on a single cell labeled value. To the left, a chaotic pile of mismatched geometric shapes represents messy data being funneled through a sleek, metallic filter that organizes them into the tidy table structure. Lighting is high-key and modern. 12.2 Manipulation Magic, Filtering and Mutating with dplyr. The workhorse of the Tidyverse is a package called dplyr. If SQL is a scalpel, dplyr is a Swiss Army knife. It uses a set of intuitive verbs to manipulate data frames. The most powerful aspect of dplyr is the pipe operator. In modern R 2026 standards, we often use the native pipe or the classic Magritte pipe %. The pipe allows you to chain commands together, passing the result of one step directly into the next. It reads like a sentence: take this data, then filter it, then summarize it. Let's look at two essential verbs, filter and mutate. Filter allows you to select specific rows based on criteria, exactly like the where clause in SQL. Mutate allows you to create new columns or modify existing ones based on calculations. Let's assume we have a data frame called sales_data. Clean_sales, sales_data. Filter, region = North America and revenue greater than 1,000. Mutate, profit_margin = revenue, cost, revenue. Notice the readability of that code block. We are taking sales_data, filtering for high revenue North American sales, and immediately calculating a profit margin for those specific rows. We didn't need to create intermediate variables or fragmented tables. This piping approach reduces cognitive load. You don't have to remember the state of the data 5 steps ago, you only need to focus on the current transformation. It keeps your logic flow linear and error-free. 12.3 Cleaning pipelines, handling missing values and dates in R. Real-world data is rarely pristine. It is full of typos, formatting errors, and the analyst's worst nightmare, missing values, represented as NA in R. If you try to calculate the average of a column that contains an NA, R will often return NA as the result, a protective measure to warn you that your data is incomplete. To handle this, we can use the drop_NA function from the tidyr package to remove incomplete rows, or we can impute values. For certification purposes, identifying and removing them is often the safest first step. Hash removing rows where the customer_ID is missing. Cleaned_data or raw_data. Drop_NA, customer_ID. The second major hurdle is date formatting. Excel often mangles dates, and CSV files store them as plain text strings. If R reads a date as the 15th of January 2026 text, rather than a date object, you cannot perform time-based analysis. Enter Lubridate. This package makes working with dates intuitive. It includes functions like YMD, year month day, or MDY, month day year, that intelligently parse strings into usable date objects. Library, Lubridate. Hash converting a text column to a date object. Data_with_dates cleaned_data. Mutate, order_date equals MDY, order_date_string. By combining dplyr for manipulation, tidyr for missing values, and lubridate for time, you create a robust cleaning pipeline. This script can be run every time you receive a new dataset, automating hours of manual Excel work in seconds. Figure, extra detailed AI-ready prompt for AI-generated diagram illustrating a data cleaning pipeline. A conveyor belt moves from left to right. On the left, raw data blocks enter, looking dirty, cracked, and covered in digital noise, glitch effects. They pass through 3 stations. 1. A robotic arm labeled drop_NA removing broken blocks. 2. A washing station labeled janitor clean_names polishing the blocks. 3. A clock-like mechanism labeled lubridate stamping a time format onto them. On the right, clean data blocks emerge, shiny, uniform, and stacked neatly. The style is clean, vector art with a professional blue and gray color palette. 12-point for grammar of graphics, building stunning plots with Plot 2. In Chapter 10, we used Tableau to drag and drop visualizations. Plot 2 takes a different approach. It is based on the grammar of graphics, a theoretical framework that breaks every chart down into its component layers. Instead of selecting a bar chart from a menu, you build the chart from the ground up. You start with the data, map the aesthetics, what acts as X, Y, color, or size, and then add geometries, points, bars, lines. This layering system gives you infinite flexibility. You are not constrained by preset templates. If you want to overlay a line chart on a scatter plot and facet it by region, you simply add another layer to the code. Hash a basic plot structure. Plot data equals clean_sales, mapping equals AES, X equals order_date, Y equals revenue, plus GM_point, color equals blue, alpha equals 0.5, plus hash the geometry layer, scatter plot. GM_smooth, method equals LM, color equals red, plus hash adding a trend line layer. Labs, title equals revenue over time, X equals date, Y equals revenue, dollar, plus. Theme_minimal, hash applying a clean visual theme. In the code above, AES stands for aesthetics. We map the order_date to the X-axis and revenue to the Y-axis. We then add GM_point to draw the dots and GM_smooth to draw a trend line. This might feel more tedious than Tableau at first. However, the power lies in reproducibility. Once you have written this code, you can apply it to 50 different datasets instantly. You can customize the theme to match your company's precise branding colors and fonts, ensuring every chart you produce looks uniform. 12.5 A Markdown, weaving code and commentary into professional reports. You have cleaned your data and created your visualizations. Now, you need to deliver the insights. In the past, this meant copying a chart from Excel, pasting it into PowerPoint, and typing a summary. If the data changed, you had to redo the entire manual process. A Markdown solves this problem effectively. It allows you to write a single document that contains your commentary, narrative, your code, and the output of that code, plots and tables. When you init an R Markdown file, R executes the code chunks and embeds the results directly into the final document. You can export this as an HTML file, a PDF, or even a Word document. Analysis of Q1 sales. We observed a significant uptick in revenue during March. Our sales_plot, echo equals false. Plot, sales_data, AES, X equals month, Y equals revenue, plus GM_col. In the example above, the text provides the context, and the gray code block generates the chart. If your source data updates next month, you simply click Knit again, and the entire report updates automatically. This is the pinnacle of the share phase in the data life cycle. You are providing stakeholders with a transparent, reproducible audit trail of your analysis. It builds immense trust because your methodology is open for review, not hidden inside complex spreadsheet formulas. By mastering our Markdown, you transition from a data analyst who just finds numbers to a data storyteller who builds automated, intelligent reporting systems. You are now ready to tackle complex case studies with a full arsenal of tools.
Chapter 13, The Capstone Strategy, Building a Portfolio-Ready Case Study. Sections, Section 13.1, Choosing a Track, Guided Projects versus Open-Ended Data, Section 13.2, Structuring Your Case Study, From Problem Statement to Recommendation, Section 13.3, Executing the Full Life Cycle, Documenting Your Process Step by Step, Section 13.4, Polishing the Deliverables, Presentation Slides and GitHub Repositories, Section 13.5, Peer Review Simulation, Critiquing Your Own Work Before Publishing. In Chapter 12, you unlocked the power of R for data wrangling and visualization. You moved from clicking buttons to writing scripts, giving you the ability to document and automate your work. Over the last 12 chapters, you have built a formidable arsenal: spreadsheets, SQL, Tableau, and R. Now, you face the final hurdle. In the Google Data Analytics Professional Certificate, this is known as the Capstone Project. But in the real world, this is known as Proof of Competence. Certificates get your resume through the Applicant Tracking System, ATS, but portfolios get you the interview. Hiring managers are less interested in the fact that you *no SQL syntax and more interested in seeing how you *apply it to solve a messy, ambiguous business problem. A well-executed case study is the difference between saying I am a data analyst and proving it. This chapter is your strategic roadmap. We will not be learning new syntax here. Instead, we are shifting gears to project management, storytelling, and professional presentation. We will take the technical skills you have mastered and package them into a compelling narrative that demonstrates your readiness for the job market. 13.1 Choosing a Track, Guided Projects versus Open-Ended Data. The certificate program typically offers two paths for your capstone. The first is a guided project, often involving a fictional company like Cyclistic, a bike share company, or Bellabeat, a wellness technology company. The second path is an open-ended project where you select your own public dataset. The guided track provides a clear business question and structured data. It acts as a set of training wheels, ensuring you don't get stuck on the initial scoping phase. If you are feeling shaky on the fundamentals, there is no shame in choosing this route to build confidence. However, if you want to stand out in a competitive job market in 2026, I strongly recommend the open-ended track. Hiring managers see hundreds of Cyclistic case studies. They all look somewhat similar. Choosing a unique dataset, perhaps related to an industry you are passionate about, like healthcare, finance, or even esports, shows initiative and curiosity. If you choose the open path, you must be careful not to drown in complexity. You need a dataset that is rich enough to yield insights but clean enough to analyze within a reasonable time frame. Sources like Kaggle, Google Dataset Search, or government data portals are excellent starting points. Figure, illustration of a fork in the road. The left path is paved and labeled guided track, safe, structured, common. The right path is a hiking trail labeled open track, unique, challenging, high reward. A hiker with a backpack labeled analyst is contemplating the map. The lighting is dawn, suggesting the start of a journey. Whichever path you choose, the goal remains the same. You are not just crunching numbers, you are simulating the life of a junior data analyst. Treat the dataset as if it belongs to a real client who is waiting for your answer. 13.2 Structuring your case study, from problem statement to recommendation. A common mistake new analysts make is diving straight into the data without a plan. They open the CSV file, start making charts, and hope an insight jumps out. This is the shotgun approach, and it rarely works in a professional setting. You must anchor your project in the 6 phases of the data analysis lifecycle we discussed in Chapter 1, ask, prepare, process, analyze, share, and act ***. Your case study structure should mirror these phases explicitly. Start with a clear *** problem statement ***. What is the business trying to achieve? For example, how can we convert casual riders into annual members? Is a specific, measurable business problem. If you cannot articulate the problem in 2 sentences, you are not ready to touch the data. Next, outline your hypotheses ***. What do you suspect the data might show? Writing these down beforehand prevents bias. It forces you to test your assumptions rather than just looking for data that supports them. Figure, a flowchart diagram showing the case study narrative arc steps. 1. Business task, the why. 2. Data sources, the what. 3. Cleaning log, the how. 4. Analysis and visuals, the result. 5. Recommendations, the action. Arrows connect the boxes in a linear flow, with a loop back from recommendations to business task to show alignment. Finally, plan your *** deliverables ***. Will you produce a slide deck? A dashboard? A written report? Knowing your endpoint helps you decide which tools to use. If the stakeholder needs a recurring report, build a Tableau dashboard. If they need a one-time deep dive, an R Markdown report might be best. 13.3 Executing the full lifecycle, documenting your process step by step. The process and analyze phases are where you do the heavy lifting. However, for a portfolio, the **doing** is less important than the *documenting star. A hiring manager needs to see your thought process, not just the final chart. If you are using SQL, save every query. Add comments to your code explaining **why you filtered out null values or **why you chose a left join over an inner join. If you are using R, this is where R Markdown, discussed in Chapter 12, shines. It allows you to weave narrative text and code chunks together seamlessly. Do not hide your struggles. Did you find duplicate records? Did date formats break your import? Document how you fixed them. This shows resilience and attention to detail. A clean dataset that magically appears raises suspicion. A dataset that was cleaned through documented steps shows competence. SQL. Example of documented SQL for a portfolio. Task: remove trips longer than 24 hours, outliers, and shorter than 1 minute, errors. Reason: these likely represent system errors or stolen bikes, skewing average duration. Select: trip _ID, start _time, end _time, trip _duration _minutes. From: bike _trips. Where? Trip _duration _minutes 1 and trip _duration _minutes less than 1,440. When you reach the analysis phase, focus on trends and relationships. Use the visualization principles from Chapter 8 to create charts that are clear and honest. Avoid the temptation to include every chart you made, only include the ones that drive the story forward. 13.4 Polishing the deliverables, presentation slides and GitHub repositories. Once the analysis is complete, you must package it. You generally need 2 artifacts, a technical repository for other analysts to review, and a business presentation for stakeholders. For the technical side, GitHub is the industry standard. Create a repository for your project. It should include your raw data, if the license permits, your scripts, SQL or R, and a readme.md file. The README is critical. It is the cover letter for your code. It should summarize the project, list the tools used, and provide instructions on how to run your analysis. For the business side, create a slide deck. Remember the lessons from Chapter 10, executives have limited time. Your first slide should be an executive summary that states the problem and the recommended solution immediately. The subsequent slides provide the supporting evidence. Figure: a split-screen visual comparison. On the left, a GitHub repository interface showing a clean file structure, data, scripts, readme.md, with a professional profile picture. On the right, a presentation slide showing a clear title, one key chart, and 3 bullet points of insights. The style is modern and corporate. Your recommendations must be actionable. Data shows weekend usage is high is an observation. Increase marketing spend on Saturday mornings to target weekend riders is a recommendation. The ACT phase depends on you bridging the gap between math and business strategy. 13.5 Peer review simulation, critiquing your own work before publishing. Before you hit publish on LinkedIn or submit your capstone, you need to simulate a peer review. In a professional environment, your code and logic would be scrutinized by a senior analyst. Since you are working solo, you must critique yourself objectively. Run your work through the so what? Test. Look at every chart in your presentation and ask, so what? If the chart doesn't help answer the business question or lead to a recommendation, delete it. Clutter dilutes your message. Check your formatting consistency. Are your fonts the same across all slides? Do your charts use a consistent color palette? These small details signal professionalism. A sloppy slide deck suggests sloppy analysis. Finally, verify your data privacy and accessibility. Ensure you haven't accidentally exposed personally identifiable information, PII. Check that your colors are colorblind friendly. When you are confident that your work is rigorous, ethical, and polished, you are ready to share it with the world. Summary. The capstone project is your bridge from student to professional. By choosing a distinct track, structuring your narrative around business value, meticulously documenting your process, and polishing your deliverables, you create a portfolio piece that works for you even when you are sleeping. You have mastered the technical tools. You have learned the theory. You have built the strategy. Now, it is time to look forward to the future of this industry. In the final chapter, we will discuss navigating the job market, acing the technical interview, and continuing your education in a field that never stops evolving.
Chapter 14, Navigating the Job Market, Branding and Interviews. Sections, Section 14.1, Translating Bootcamp Skills into Resume Keywords, Section 14.2, Optimizing your LinkedIn profile for recruiter visibility, Section 14.3, The Technical Interview, Whiteboarding SQL and Explaining Logic, Section 14.4, Behavioral Questions, Showcasing Soft Skills and Adaptability, Section 14.5, Networking Strategies, Finding Mentors and Hidden Opportunities. In Chapter 13, you crossed the finish line of the technical curriculum. You selected a data set, cleaned it, visualized the results, and compiled a portfolio-ready case study. You have proven to yourself that you can do the work. Now, you must prove it to someone else. The transition from student to candidate is often the most anxiety-inducing part of the process. You might feel a touch of imposter syndrome, wondering if your bootcamp projects can truly stand up against candidates with computer science degrees. Let me assure you, they can. Hiring managers in 2026 are less obsessed with pedigree and more focused on capability. They want problem solvers who can communicate data insights clearly. However, you cannot rely solely on your skills to speak for themselves. You must become the marketer of your own talent. In this chapter, we will bridge the gap between your technical ability and your employment reality. We will translate your bootcamp experience into language that recruiters value, demystify the technical interview, and build a personal brand that opens doors before you even knock. 14.1 Translating Bootcamp Skills into Resume Keywords. The first gatekeeper you will face is rarely a human being. It is the applicant tracking system, ATS. This software scans thousands of resumes, looking for specific matches to the job description. If you don't speak the language of the ATS, your beautifully designed Tableau dashboard may never be seen by human eyes. Many career switchers make the mistake of listing generic duties like completed coursework. Instead, you must translate your learning into competencies. You haven't just learned SQL, you have performed data extraction and aggregation. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a resume transformation visual. Split screen layout. On the left, a crumpled paper titled Student Resume lists vague bullet points like watched videos on art and did a capstone. On the right, a sleek, glowing digital document titled Analyst Resume highlights action verbs in gold text, engineered, optimized, visualized. A magnifying glass hovers over the right side, revealing keywords matching a job description background. Professional, clean vector art style, blue and white color palette. To pass the ATS scan, focus on the Tools plus Action formula. For every tool you list, attach a verb that describes a business outcome. Here is a guide to translating the skills we have covered in this book into professional resume bullet points. Skill area: student phrasing, avoid; professional phrasing, adopt. Do not simply list your capstone project as coursework. List it as experience or projects. Give it a professional title, such as Customer Churn Analysis. Treat your bootcamp tenure as a job simulation. You showed up, you met deadlines, and you produced deliverables. Reflect that professionalism in your document structure. 14.2 Optimizing your LinkedIn profile for recruiter visibility. Your resume is a push mechanism, you send it out. LinkedIn is a pull mechanism, it brings opportunities to you. In the data analytics field, recruiters heavily utilize LinkedIn Recruiter to headhunt candidates based on specific criteria. Your profile headline is the most valuable real estate you own. Aspiring data analyst is weak, it suggests you are not ready. Data analyst SQL, Tableau, are certified transforming data into insights establishes your identity immediately. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a LinkedIn heat map. A mock LinkedIn profile layout is shown. Hot zones, red and orange, indicate where recruiter eyes focus, the profile picture, the headline, the featured section with thumbnail images of dashboards, and the skills list. Cooler zones, blue, cover the dense text of the About section. A semi-transparent overlay shows a recruiter's cursor hovering over a View Portfolio button. Modern UI design, heat map style visualization. The About section, this is your elevator pitch. Tell your story. If you are a career switcher from retail or healthcare, frame your background as an asset. Asterisk example, with 5 years of experience in retail management, I understand the questions business leaders ask. Now, I use SQL and Tableau to answer those questions with data. The featured section, this is where your Chapter 13 capstone shines. Do not just post a link to a GitHub repository. Post a screenshot of your dashboard or a PDF of your slide deck. Visuals arrest the scroll. Skill endorsements, ensure your skills section is updated with the hard skills we have mastered: SQL, R programming, Tableau, data visualization, and spreadsheet modeling. Take the LinkedIn skill assessments if available, earning that badge verifies your competency to the algorithm. 14.3 The technical interview, whiteboarding SQL and explaining logic. If your resume works, you get the interview. The first stage is usually a behavioral screen, but the second stage is the one that terrifies most candidates, the technical screen. You may be asked to write SQL on a whiteboard or a shared Google Doc while the interview watches. The goal here is not necessarily to write syntactically perfect code on the first try. The goal is to demonstrate your logic. When an interview gives you a problem, do not immediately start writing code. Step 1. Clarify the requirement. Ask questions. Are there duplicate records? What is the primary key? How should we handle null values? This shows you think like an analyst who cares about data quality. Step 2. Talk through your logic. Narrate your thought process. I need to find the top 5 customers by revenue. First, I'll need to join the customers table with the orders table. Then I'll sum the order amounts and group by customer ID. Step 3. Write the code. Use the structure we practiced in Chapter 7 and 8. Interview prompt: find the top 3 cities with the highest average order value. Select city. Average, order underscore total, AS average underscore value. From customer underscore orders. Group by city. Order by average underscore value desk. Limit 3. Step 4. Review and refine. Before saying I'm done, check your work aloud. I see I used average. I should check if there are any outliers skewing this mean. If so, a median might be better, but for this SQL exercise, the average serves the request. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a whiteboard interview scene. A perspective shot of a glass whiteboard in a modern office. On the glass, handwritten SQL code is written in blue marker, with arrows drawn in red marker connecting the join clause to a small schema diagram drawn in the corner. A hand holds a marker, pausing. The background is slightly blurred, showing a supportive interview nodding. Lighting is bright and professional, emphasizing clarity and thought process. If you get stuck, admit it calmly. I'm drawing a blank on the specific function name for date formatting in this dialect, but conceptually, I would extract the month here to group by season. This is acceptable, panic is not. 14 point for behavioral questions, showcasing soft skills and adaptability. You cannot code your way out of a bad personality fit. Companies hire people they want to work with. Behavioral questions test your soft skills, communication, resilience, and adaptability. The gold standard for answering these is the STAR method: situation, task, action, result. Let's look at a common question: tell me about a time you had to handle messy data or a difficult problem. Situation: during my capstone project analyzing bike share data. Task: I needed to calculate trip duration, but the dataset had thousands of negative values and missing timestamps. Action: I didn't just delete them. I used R to investigate the source of the errors. I identified that the negative values corresponded to maintenance checks. I filtered these out and documented the exclusion in my changelog. Result: this preserved the integrity of the analysis, allowing me to deliver an accurate report on actual customer usage, which revealed a 15% upward trend in weekend rides. Notice that the action part is the longest. Many candidates spend too much time setting the scene. The interview wants to know what you did. Prepare 3 pocket stories before your interview. 1. A time you solved a technical conflict. 2. A time you learned something new quickly. Your bootcamp journey fits here. 3. A time you communicated a difficult finding to a stakeholder. 14.5 Networking strategies, finding mentors and hidden opportunities. The hidden job market refers to roles that are filled through referrals before they are ever posted on job boards. To access this, you need a network. Networking is not about begging for a job. It is about curiosity. Reach out to data analysts who are 2 to 3 years ahead of you. They are often more helpful than directors or VPs because they remember exactly what it feels like to be in your shoes. The informational interview request: keep it short. Hi, name: I recently finished a data analytics bootcamp and I admire your career path at company. I'm not looking for a job, but I would love 15 minutes of your time to ask how you transitioned into the field. Your perspective would be invaluable. When you meet, ask about their tools, their daily challenges, and what they wish they knew when they started. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a network web concept. In the center, a node labeled U. Lines radiate out to nodes labeled peers, mentors, alumni, and recruiters. The connections between nodes are glowing, suggesting active data flow. Icons represent different interactions: a coffee cup for meetings, a message bubble for LinkedIn, and a handshake for events. The background is a dark, tech-inspired navy with data stream particles. High-tech, interconnected visualization. Attend local meetups or virtual hackathons. Contribute to open source data projects. Every interaction is a seed planted. You are no longer just a student studying in isolation, you are a member of a global community of data professionals. Conclusion: you are ready. Over the last 14 chapters, we have traveled from the philosophical definition of data to the granular syntax of our code. You have built dashboards, queried databases, and structured your professional identity. The Google Data Analytics Professional Certificate curriculum provides the map, but you have walked the path. Do not wait for permission to call yourself a data analyst. If you are querying data to answer questions, you are doing the work. The job search may take time. You may face rejections. This is normal. Treat the job search as a data project in itself, track your applications, analyze which resume versions get responses, and iterate on your approach. You have the tools. You have the portfolio. Now, go find your data.
Chapter 15, Beyond the Certificate, AI, Machine Learning, and Life Analysis. Sections, Section 15.1, The 2026 Landscape, How AI Assistants Are Changing Entry-Level Roles, Section 15.2, Introduction to Python, The Next Logical Step in Your Education, Section 15.3, Domain Specialization, Finance, Healthcare, and Marketing Analytics, Section 15.4, Staying Current, Blogs, Communities, and Continuous Learning, Section 15.5, Final Words, Embracing the Forever Student Mindset. In Chapter 14, we navigated the complexities of the job market. We polished your resume, optimized your LinkedIn profile, and prepared you to walk into an interview room with confidence. You are now ready to land the job. But getting the job is simply the act of walking through the door. The real challenge and the real excitement begins once you sit down at the desk. The world of data analytics is not static. The tools we used in Chapter 10 may look different 5 years from now. The syntax we mastered in Chapter 12 might be automated by Chapter 15 of your own career. This final chapter is not about passing a test. It is about future-proofing the career you have worked so hard to launch. We are going to look at the horizon of 2026 and beyond, discussing how artificial intelligence is reshaping the analyst's workflow, why Python is your next best friend, and how to maintain the mindset of a lifelong learner. 15.1 The 2026 Landscape, How AI Assistants Are Changing Entry-Level Roles. When I started in this industry, automation meant writing a macro in Excel. Today, automation implies a collaborative relationship with artificial intelligence. By 2026, the entry-level data analyst role has shifted. You are no longer just a writer of code, you are an auditor of code. AI assistants like GitHub Copilot, ChatGPT, and Gemini are integrated directly into our IDEs and BI tools. This does not mean your job is disappearing. It means the drudgery is disappearing. Figure, photorealistic, high-resolution image of a modern dual-monitor workspace. On the left screen, a complex SQL query is visible with highlighted syntax suggestions from an AI assistant. On the right screen, a clean, colorful data visualization is emerging. Soft, warm lighting illuminates the desk, emphasizing a coffee mug and a notebook, suggesting a human-centric workflow augmented by technology. Cinematic depth of field. In the past, if you forgot the specific syntax for a left join or a complex regular expression, you stopped working to search Google. Now, your AI assistant suggests the snippet before you finish typing the line. However, this convenience creates a trap for the lazy analyst. If you rely entirely on AI to write your SQL queries, you will not know when the AI is wrong. And AI will be wrong. The value of the Google Data Analytics Professional Certificate lies in the foundation it gave you. You understand the logic of data cleaning. You know why a join might duplicate rows. Because you possess this foundational knowledge, you can use AI as a force multiplier rather than a crutch. In 2026, the best analysts are the ones who can ask the AI the best questions. We call this prompt engineering, but it is really just clear, logical communication, the same skill you use to present stakeholders with insights in Chapter 10. 15.2 Introduction to Python, the next logical step in your education. Throughout this bootcamp, we championed the R programming language. It is fantastic for statistical analysis and visualization. However, if you look at job descriptions for data scientist or machine learning engineer, you will notice a different dominant language, Python. I often describe the difference this way. R is a specialized scalpel designed for surgeons, statisticians. Python is a Swiss Army knife designed for engineers. As you advance your career, you will likely encounter scenarios where you need to integrate your analysis into a web application or automate a task on a server. Python excels here. Moving from R to Python is easier than learning R was in the first place. You already understand variables, vectors, lists, and data frames. You are simply learning a new dialect. For example, look at how we load a dataset in Python using a library called pandas. It looks remarkably similar to the tidyverse approach you learned in Chapter 12. Import pandas as PD. Loading a dataset in Python. df equals pd read underscore csv, sales underscore data underscore 2026.csv. Filtering data, similar to filter, in R. High underscore revenue equals df, revenue, greater than 5,000. Display the first few rows. Print, high underscore revenue dot head. Notice the logic remains the same, only the syntax shifts. Learning Python opens the door to machine learning, ML. While R has ML capabilities, Python is the industry standard for production-grade AI. Libraries like scikit-learn and TensorFlow allow you to move from analyzing past data to predicting future outcomes. You do not need to rush this. Master the tools you have learned in this course first. But when you feel the itch to expand, let Python be your next destination. 15.3 Domain Specialization, Finance, Healthcare, and Marketing Analytics. One of the most common questions I hear from graduates is, how do I stand out when everyone has the same certificate? The answer is domain specialization. A generalist data analyst is a junior role. A healthcare data analyst or a fintech analyst is a specialized professional who commands a higher salary and greater respect. To accelerate your career, combine your new data skills with the industry knowledge you already possess or have an interest in. The T-shaped professional. Visualize your skills as the letter T. The horizontal bar represents your broad data skills, SQL, Tableau, R, and communication. The vertical bar represents deep knowledge in one specific sector. Finance. Here, precision is everything. You will deal with time series data, risk modeling, and fraud detection. Accuracy is valued over aesthetics. Figure. A clean, minimalist infographic diagram on a white background. It depicts a T-shaped employee model. The horizontal bar is labeled Data Analytics Foundation with icons for SQL, spreadsheets, and visualization. The vertical bar extends downward, labeled Domain Expertise, branching into three colored sections: Finance, Risk Fraud, Healthcare, Patient Outcomes, and Marketing, Customer Acquisition. The design is modern, using flat vector art. Healthcare. This field requires navigating privacy laws, like HIPAA in the US, and handling messy, unstructured text data from doctors' notes. The goal is often improving patient outcomes or operational efficiency. Marketing. This is fast-paced and experimental. You will analyze A/B tests, customer acquisition costs, CAC, and social media sentiment. Speed and storytelling are often valued over perfect statistical rigor. Don't discard your past experiences. If you worked in retail for 10 years, you are not starting over as an analyst. You are a retail analytics specialist. You understand supply chains and customer behavior in ways a fresh computer science graduate does not. Lean into that. 15.4 Staying current, blogs, communities, and continuous learning. The rate of change in technology can induce anxiety. We call this techno-stress. You might feel that if you stop learning for a weekend, you will fall behind. Let me offer a calming thought. Fundamentals change slowly. Tools change quickly. If you understand the fundamentals of data integrity, Chapter 4, and Visualization Theory, Chapter 10, you can learn any new tool in a week. However, staying plugged into the community helps you spot trends before they become requirements. Here is how to curate a just-in-time learning ecosystem. Curate your feed. Follow hashtags like #DataAnalytics and #TidyTuesday on LinkedIn and X, formerly Twitter. Seeing what others are building provides inspiration. Read engineering blogs. Companies like Netflix, Uber, and Airbnb publish engineering blogs. They explain how they solve data problems. Even if the technical details go over your head, understanding the business logic is invaluable. Local meetups. Nothing replaces face-to-face interaction. Look for Data Saturdays or local Python user groups. These are safe spaces to admit what you don't know and find mentors. GitHub. Review code written by others. It is the single fastest way to learn best practices. Avoid the trap of just-in-case learning, trying to learn every new tool just in case you might need it. Focus on just-in-time learning, learning the tool you need to solve the problem directly in front of you. 15.5 Final words. Embracing the forever student mindset. We have reached the end of this book, but the beginning of your practice. When you started Chapter 1, you were likely looking for a career change. You wanted a better salary, more remote options, or simply work that felt more intellectually stimulating. These are noble goals. But I hope that over these 15 chapters, you have found something else, a new way of seeing the world. Data analysis is not just a job, it is a mindset. It is the refusal to accept "I think" when I know is available. It is the curiosity to dig deeper when a number looks off. It is the integrity to report the truth, even when the truth is inconvenient for stakeholders. You will encounter imposter syndrome. You will break databases, hopefully in a development environment. You will write code that fails. This is not failure, this is the data collection phase of your own life. Analyze your failures. Clean up the messy parts of your workflow. Visualize where you want to go next. You have the toolkit. You have the foundation. Now, go find your insights. Welcome to the community.